Let's start. Good morning po sa lahat. Again, maraming salamat po ulit sa pagsama sa amin sa aming seminar for today. So ngayong araw po, magkakaroon po tayo ng lecture, web lecture 2 na handog sa inyo ng Filipino Science Hub. Kuya JP, next slide please. So bago po tayo magsimula sa ating webinar, gusto ko lang po ulitin yung mga pointers. So paki-mute na lang po yung inyong mga device, microphone, and keep your cameras turned off para po hindi bumagal yung ating reception. Reserve questions toward the end of the presentation, and if you have questions, send them on Zoom chat box or YouTube live comment section, and please no recording of the session via your personal devices. Next slide, please. So after the lecture, if you have questions, we will entertain some questions for 30 minutes. And for the certificates, we will be issuing certificates to Zoom and YouTube participants who are Filipino Science Hub followers. So kung hindi nyo pa po kami na-follow sa Facebook, pa-follow na lang po. And doon naman po sa mga nanonood sa YouTube, if hindi pa kayo nakasubscribe, please subscribe to our channel na lang po para makakuha po tayo ng certificates. And the link for the form for you to get the certificate will be posted in the comment box on YouTube Live and Zoom. And slides will not be shared, but the web lecture will be uploaded in YouTube and in Facebook. Next slide, please. And to introduce our team, I will call on Kuya JP.
Hello, good morning everyone. Introduce ko lang po yung page, especially po, para po doon sa mga first time po na sumama sa amin. So we have been doing this for 3 months already. We are the Filipino Science Hub, and we were founded in 2012 by Dr. Jeffrey Bungkin as the Batangas City Science Teachers Hub. And yung layunin po talaga namin is to create a platform na nagpo-promote po ng science and technology, engineering and mathematics, so STEM, as we know today as STEM, dito sa Pilipinas. And we started to put up lectures and webinars online. And gusto pa po sana namin siyang palawakin para po marami pa po tayong subject areas na matackle next time. And for now, ganito lang po muna yung setup natin. And we are a 6-man team. So wala pa pala si Ralph dito. So including myself, JP Onya, Dr. Janice Averilla, Dr. Medjo Anagila, John Marty Mateo, our host, and of course, Ralph Alumia, who is also a professor in UPLB, and Dr. Jeffrey Bungkin, our founder. So magabang lang po tayo ng mga online events natin, and we still have a lot of materials to share, and sana po patuloy niyo po kaming suportahan. Thank you po.
Thank you, Kuya JP. So we will now proceed to the lecture. So for today, we will be having our founder, Dr. Jeffrey Bungkin, to discuss a basic concept in chemistry na medyo mahirap sa una kapag hindi mo pa siya na-master. Actually, Lewis theory and chemical bonding is sobrang basic niya pagdating sa chemistry. Kailangan natin siyang matutunan. Nung high school ako, hindi ko rin siya masyadong gets kung paano siya ginagawa until mag-college pa. Actually, si Kuya Jeff yung nagturo sa akin kung paano ang gumawa ng Lewis structure kasi dormmates kami dati nung undergrad pa ako. So, I guess he is the perfect person para magturo po sa mga teachers natin ng ganitong concept kasi napaliwanag niya sa akin ng maayos to nung undergrad ako. So, without further ado, can we have Kuya Jeff for the lecture? Oh, meron pa pala. So,
yeah.
Mamaya na yon, after na lang.
Or after na lang. Sige, sige.
Ayan, sige, announce na natin. So, announce na natin para isang ano na lang. Sorry, Kuya JP. So, para naman po dun sa mga teachers na nanghihingi ng advice for science investigatory projects, ito po magkakaroon po tayo ng online kapihan 2 featuring Professor Ralph Alumia. So, si Professor Ralph po ay nagme-mentor ng mga students and teachers sa San Pablo City Science High School. So, isi-share po niya yung culture of research among high school students in San Pablo City, Laguna, best practices in the implementation of science investigatory projects. So, yung mga natuturuan po at mini-mentor ni Sir Ralph ay nananalo po ng mga awards or napipili po na nasa top ng sa buong Laguna at lumalaban din po sa ibang provinces. So, ito po ay mangyayari sa July 11, 10:30 a.m. So, kung kayo po ay libre at wala po kayong gagawin, pwede po kayong, marami po actually ang nagsagot dun sa poll namin before na gusto po nilang matuto ng mas marami sa science investigatory projects. Kaya po, tinugon po ng PhilSci Hub yung inyong mga sagot, ay yung sagot nyo dun sa poll. So, meron pa ba tayong announcement, Kuya? Wala na. So, let's start with the lecture. Kuya Jeff, I'll give you the floor.
So, heads up lang po, our lecture po is 2.5 hours. Dalawat kalahating oras po siya. So, feel free po to have your lunch or take some bio breaks in between kasi medyo mahaba po siya. And ayun po, sana po sama-sama tayong matuto.
Po sa ating lahat. Muli, ako po si Jeffrey Bunkin, ang founder ng Filipino Science Hub. At welcome po sa ating pangalawang web lecture. So sa araw pong ito, ang ating pong web lecture ay nakafocus sa konsepto ng Lewis theory at ang chemical bonding. Pero bago po tayo magpasimula, gusto ko muna po uling magpakilala para po sa ating mga manonood na baka po hindi pa masyadong pamilyar sa Filipino Science Hub at sa akin po bilang web lecturer ninyo. So ako po si Jeffrey Bunkin, isa po akong Filipino scientist na nakabase dito sa Estados Unidos. Ako po ay nagtapos ng kursong chemistry sa University of the Philippines. Pagkatapos po noon, ako po ay nag-aral, kumuha po ako ng aking doctorate degree in chemistry sa University of Alberta in Canada. At pagkatapos po noon, ako po ay lumipat sa Amerika kung saan ako po ay nagtrabaho sa Argonne National Laboratory bilang isang research scientist sa area of energy research. Pagkatapos naman po noon, ako po ay lumipat sa private industry at kasalukuyan po ako ay naandito sa Houston, Texas at nagtatrabaho bilang isang research engineer para sa isang petrochemical company. So, pagkatapos po ng aking pag-aaral sa Universidad ng Pilipinas, ako po ay nagpakadalubhasa sa area ng catalysis, materials engineering at maging sa area po ng process development. At over the course of time po, I have already published about like 16 international publications and I have more than 20 inventions covered by patents. So yun po. So sa araw pong ito, ako po ay magbabahagi sa inyong lahat ng aking kaalaman tungkol sa Lewis theory at sa konsepto ng chemical bonding. Ngunit gusto ko lamang din pong ipabatid para po sa ating mga manonood, ito pong ating lecture na ito ay dedicated po sa ating mga guro na siguro po medyo hindi ganon ka lalim ang pagkakaintindi sa Lewis theory, sa konsepto ng chemical bonding. Ito pong kursong ito ay amin pong inihahandog bilang refresher po para po sa ating mga guro. Ang lengguwahe po na ating ginamit dito ay Taglish para po mas mapadali rin ang pagkakaintindi kung meron po tayong mga estudyante na nakapanood. Gusto ko lang din pong sabihin na kung meron po dito mga eksperto pagdating sa mga konseptong ito, maaari pong ito pong session na ito ay hindi po akma para sa inyo. Ano po, ang particular po namin ginawa sa web lecture na ito ay hinimay po namin talaga ng maigi ang pamamaraan sa kung paano ba natin isosolve ang mga problems related to the Lewis theory, to drawing Lewis structures, and when it comes to writing Lewis symbols. Isang paghingi din po ng paumanhin, medyo mahaba po itong lecture natin ito, mahigit 2 oras po ito. Ito ay dahil kinailangan po talaga namin magbigay ng napakaraming examples para po maipakita natin yung tamang pamamaraan ng pagsulat ng or pagdraw ng Lewis structure. So simula po sa pinakasimpleng compounds hanggang sa medyo mas komplikado na. So yun po, maaari pong habang ako ay nagtuturo dito, pwede po kayong kumain at the comforts of your home. Pero yun po, nawa po ay mapag-ukulan ninyo ng oras itong paghahandog na ginawa po namin para sa inyo. So nawa po ay marami kayong matutunan at marami po kayong mabaon mula sa lecture na ito.
Stable ng internet.
So narito po ang overview ng ating discussion para sa araw na ito. So sisimulan po natin ito sa pagbabalik na sa Lewis theory. So sino ba ang nakadiscover o sino ba ang nag-propose ng Lewis theory? Ano ba yung main teachings ng teoryang ito? Pangalawa po, susundan natin ito ng pag-discuss sa kung paano ba ang pagsulat ng Lewis symbols or ang pagdraw ng Lewis structures ng elements at ng compounds. In particular, magkakaroon din po tayo ng discussion sa dalawang klase ng chemical bonding. Ito ay ang ionic bonding at ang covalent bonding. And then about 75% po of the entire session will be spent on solving problems asking for us to draw the Lewis structures or symbols of ionic and covalent compounds. So I highly encourage all of you po to have your pens and papers ready for you to be able to solve all of these problems with me. So meron po tayong 2 oras para dyan. Bago po tayo tumungkol sa ating discussion proper, gusto ko muna po uling ibahagi sa inyo itong aking konsepto ng learning of chemistry by heart or learning science by heart. So, kaparehas po na ginawa natin noong unang web lecture, sisimulan po natin ang ating discussion sa pagbabalik tanaw. Ano ba yung history behind the Lewis concept? Pagkatapos po noon, what we will do is that we will try, or I will try, to give you a very good visualization of the concepts or the principles behind the Lewis theory or behind chemical bonding. Pagkatapos po noon, magpa-practice po tayo sa napakaraming examples. So para po mas tumatak po sa atin yung mga strategies, yung systematic steps that will enable us to draw the right Lewis structures para maituro natin ito ng mas klaro at mas enjoyable at mas madali para sa ating mga mag-aaral. Okay, so bakit ba natin kailangang aralin ang chemical bonding at ang Lewis theory in particular? So that is because, whenever we study chemistry, typically kapag po nag-aaral tayo ng compounds, we are given its molecular formula. However, may limitasyon po kung ano lang ang impormasyon na pwede natin makuha sa chemical formula or sa molecular formula. Ano lang bang meron doon? Yung atoms or elements comprising that compound. Kung ilan ang bawat elemento na meron doon sa compound na iyon. Pero it doesn't give us an idea. Paano ba nagkakadikit-dikit? Paano ba nagsasama-sama itong mga elements na ito or mga atoms na ito to form that compound? And we can only get that information if we know the concept of chemical bonding and structures. So, bakit mahalaga ang structure? So, the structures of atoms and compounds determine their chemical properties and the transformations that they undergo. So, yung tanong, bakit ba ang water ay liquid at normal conditions? So, yung property that gives water the ability to become liquid under normal conditions, so that is dictated by its chemical structure. Now, the question is, so we do have water, it's H2O in terms of its molecular formula. But the question of how do 2 hydrogen atoms and 1 oxygen atoms combine to form water? And the concept behind that is what we call chemical bonding. So there is a force that actually holds these atoms together to form the compound. At yun po ang ating aaralin ngayon. Merong iba't ibang klase ng interactions between these atoms. And then lastly, the Lewis theory is a very important tool. To be specific, it is the simplest tool that we can actually use for representing chemical bonding among elements or among atoms to form a compound. And it can also be the simplest method that can be used to come up with probable or reasonable structures of compounds. So sometime between the years of 1916 to 1919, the Lewis theory was postulated by three important scientists in history. So these are Gilbert and Lewis, Irving Lamier, and Walter Cosell. So kung mapapansin po ninyo, ipinangalan lang siya kay Lewis kasi like this theory is mostly associated with him. Pero ano ba yung nadiskubre nila? So what they proposed or they had this common observation that there is something unique about the electronic configurations of the noble gas atoms. And this special electronic configuration accounts for their inertness. Ano ba yung noble gases natin po? We have helium, neon, argon, krypton, and so on. So these noble gases, they don't react. They don't normally form compounds with other elements. And the reason for that is they are happy being by themselves. They are happy with the number of electrons that they have and the orientation of these electrons in space. Kumbaga ano na sila, fulfilled na po sila. Kumbaga sa tao, wala na silang hinahanap. Yun po. And what they have also observed is that atoms of other elements combine with one another to acquire electronic configurations like those of noble gases. So, ang sabi po nila, yung atoms of other elements other than yung noble gases, they combine. And upon combining to form compounds, they end up achieving electronic configurations or electronic properties very similar to those of the noble gases. So kumbaga po, special yung class ng noble gases. Sila po yung idol ng ibang mga elements. So yun po yung naobserbahan ni na Lewis, Langmuir, at Cosell. So in particular po, when they were doing all their investigations about the electronic configuration of the noble gases, meron pong common theme, with the exception of helium. So helium only has one orbital, which is the 1s orbital, and that orbital is completely filled with 2 electrons. So they saw that, or they discovered that if you have fully filled orbitals, then it results in stability. But in the case of neon, hanggang sa mas pabigat po na pabigat or palaki ng palaki na noble gases, they do have a common electronic configuration where yung valence shell natin or yung outermost electrons of that noble gas have completely filled s orbitals. So there are 2 electrons in the s orbitals, and they also have completely filled p orbitals. So 6 electrons for the p orbitals, and within that shell, kung pagsasamahin po natin namang ito, 2 plus 6 electrons would be equal to 8 electrons. So yung outermost orbitals po or yung outermost shell ng noble gases have 8 electrons fully occupied, and those 8 electrons in the outer shell impart stability, and that is the origin of the octet rule. So uulitin ko po, yung ibang mga elements naman other than noble gases, they combine to form compounds in order to also have an octet of electrons in their valence shells. Okay, so that is a quick look back to the history of Lewis theory. So again, tatlong scientists, but the theory has been mostly associated with Gilbert Lewis. So dumako naman tayo sa fundamentals or fundamental concepts behind Lewis theory and chemical bonding. The most important idea that you have to keep in mind is that the outer electrons or the valence electrons, so yung electrons na nasa valence shell, they play a fundamental role in chemical bonding. So yung mga elements or atoms, they combine to form chemical bonds, and the electrons responsible for chemical bonding are what we call the valence electrons. So yun lang po. mas pinasimple ito. Maraming electrons ang ibang at ibang mga elements, pero hindi sila lahat ay involved sa chemical bonding. So papakatandaan po natin yan. At sa pagsulat natin ng Lewis structures and then Lewis symbols, ang gagamitin lamang po natin ay ang valence electrons. And for this particular lecture, we will be focusing on two types of chemical bonds or two modes of chemical bonding. The first of which is what we call ionic bonding or an ionic bond. So an ionic bond forms when two atoms combine where there is a net transfer of electrons from one atom to the other. So merong transfer ng electrons. So ibig sabihin, yung maglulose ng electron, it'll form a positively charged species which we call cations. And then yung recipient naman ng electron will become negatively charged and we call them anions. And then the resulting cations and anions have electronic configurations that are stable. So yung electronic configurations ng ating charged species ay isoelectronic or kaparehas ng electronic configuration with or of noble gases. So kaya po sila namimigay ng electron, may mapapala po sila. The compounds that are formed from the combination of the cation and the anion is what we call an ionic compound. The force of attraction keeping the cation and the anion together is what we call the ionic bond. Okay, these oppositely charged ions are held together by a strong electrostatic force called an ionic bond. So medyo pansin niyo po, inuulit-ulit ko itong mga sentences na ito kasi these are very important aspects of ionic bonding. Now, yung pangalawa naman po nating example or pangalawang type ng chemical bonding is what we call covalent bonding. So covalent bonding results from the combination of at least two atoms where the electrons or the valence electrons are shared. And the sharing of electrons results in the formation of a covalent bond. So itong covalent bonding po, napakarami nating examples na gagawin mamaya. So these are rather worthy definitions or discussions of these concepts. Ano po, medyo kung ganito po natin siya ituturo sa mga estudyante natin, mawawalan agad yung attention nila kasi medyo abstract. Kailangan nila mag-imagine. If you don't have visual aids, medyo mahirap po talaga itong ituro. So in this particular lecture, papasadahan lang muna po natin yung overview ng konsepto, which we just did in the previous slide. But this time, i-define lang natin yung dalawang very important concepts. The concepts of Lewis symbol and Lewis structures. And then after that, puro na po tayo problem solving. Okay, baka hindi po aware ang karamihan sa atin. A Lewis symbol is different from a Lewis structure. So ano ba ang Lewis symbol? So a Lewis symbol is a symbol that represents the nucleus or yung atom that is involved in the chemical bonding. So it presents the core electrons of an atom together with the dots representing the valence electrons or the electrons in the outermost shell of that nucleus. So pakatandaan po, ang isa pong Lewis symbol is comprised of the chemical symbol in the form of, like one or two letters according to the periodic table. And that is decorated by the Lewis dots representing the valence electrons. So magpapakita po tayo mamaya ng maraming examples ng Lewis symbols of different elements. Okay, so now we're moving on to Lewis structures. Ano nga ba ang Lewis structure? A Lewis structure is a combination of Lewis symbols that represent either the transfer of electrons from one atom to the other, so to form an ionic bond. So we can represent ionic bonds or ionic compounds by combining Lewis symbols. In the same way, we can also represent the sharing of electrons using a combination of Lewis symbols. So again, Lewis structure is the combination of Lewis symbols that represents chemical bonding. So in order for us to effectively and accurately draw Lewis symbols and Lewis structures, we need to have a very good grasp of electronic configuration. So kailangan na iintindihan po talaga natin ang electronic configuration of different elements. At ito muna po ang una nating papracticein. Magre-review muna po tayo ng ng electronic configuration over the next 10 to 15 minutes. Okay, so narito ang ating first set of problems na gagamitin natin para mag-review ng electronic configurations. So, show the electronic configurations for first, hydrogen and helium, and then second, for fluorine, neon, and sodium.
Okay, so bago po tayo tumungo sa malalim na pagtalakay ng Lewis symbols at saka Lewis structures, mahalagang balikan muna natin ang konsepto ng electronic configuration. So magkakaroon lang po tayo ng maiksing review at magsisimula tayo sa dalawa sa pinakasimpleng elemento sa periodic table. Ito ay ang hydrogen at ang helium. Okay, so kapag ganito po ang simbolo ng elemento na binigay sa inyo at merong dalawang numero bago yung letter symbol, ano po bang ibig sabihin yan? Yung letter po na nasa baba, that corresponds to the atomic number. Ibig sabihin yun ang nagbibigay ng bilang ng protons present in that particular element. At alam po natin na kapag neutral ang element, ang number ng protons, which are positively charged subatomic particles, should be equal to the number of electrons. So in the case of hydrogen, kapag po siya ay neutral, kapag since ang kanya atomic number is 1, ibig sabihin po noon, ang kanyang number ng electron is also equal to 1. Meron siyang isang electron. So tatandaan po natin yun. So pangalawa po, yung numero na nasa taas, that corresponds to the atomic mass. So the atomic mass is the sum of the number of protons and neutrons. So dito po, in the case of hydrogen, ang kanyang atomic number is 1. But then its atomic mass is also 1. So that means na wala siyang neutron. So 0 po ang neutron ng hydrogen. That makes it a bit special. So medyo hindi niyo po siya maobserbahan sa iba pang mga elemento sa periodic table. Okay, pagdating naman sa case ng helium. So helium has an atomic number of 2. So ibig sabihin for a neutral helium atom, it has 2 protons and 2 electrons. Pagdating naman po sa atomic mass, it has a value of 4. So from this number, pwede nyo pong tanongin yung estudyante nyo, ilan po ba ang neutrons na meron itong helium? So yung helium should have 4 minus 2, which is equal to 2 neutrons. Kasi again, ang mass number is equal to the sum of protons plus neutrons. Okay, hydrogen has 1 electron, helium has 2 electrons. Okay. At ngayong nabilang na natin ang electrons sa hydrogen at sa helium, at pwede na tayong magbuo or pwede na natin gusulatin ang kanyang electronic configuration. Pero bago tayo pumunta doon, recap lang. So, sa lesson po na ito, hindi muna natin babalikan kung bakit ba yung electronic configuration is arranged in a particular manner. So ito muna po, tatanggapin muna na po natin kung ano yung mga tinuro ng mga teachers natin, but meron po tayong ibang session para dyan. So electronic configuration po natin gagamitin ngayon, na which is uniform for all of the elements, would go like this: 1s, 2s, 2p, 3s, 3p. So yung tinuro din sa atin ng mga teachers natin is yung orbital occupancy ng mga ito is 2 electrons sa s orbitals, 2 electrons sa 2s orbitals, sa 3p orbitals 6, di ba ang sabi po sa atin, sa s 2 rin, sa p 6. Bakit ba ganyan yung pagkakasunod-sunod ng orbitals? So kung mapapansin po ninyo, ang kada s at p orbital dyan ay merong numerical coefficient. So dito, this is 1, 2, 2, 3, 3. So ano ba yung number na yan? Yung number po na yan, ang tinatawag natin na quantum number. So, ang pinakasimple pong explanation na pwede nating ibigay dyan ay ang numerong iyan ang nagbibigay ng nag-i-indicate ng energy level ng electron. So, ibig sabihin, pag 1, mababa yung energy level niya. Pag mababa ang energy level ng electron, ibig sabihin, mas malapit siya sa nucleus. Mas malakas yung attraction. So yung 1s orbitals, mas malapit siya sa nucleus. Pagdating ng 2s orbital, mas malayo siya ng konti. And then 2p, and then 3s, and then 3p. So ibig sabihin yan, kapag palaki ng palaki ang quantum number nyo, palayo siya ng palayo from the nucleus. So ibig sabihin, itong 3p orbital siya na yung pinakamalayo. So sa lahat ng orbitals na mayroon dito, siya ang nakaka-experience ng pinaka mahinang attraction sa positively charged na nucleus. Bakit positively charged na nucleus? Kasi nandun yung proton. So ngayon alam na natin ang ibig sabihin ng mga numero bago ang orbital. Ang tanong naman ngayon, bakit dalawang electrons lang ang pwedeng ilagay sa 2s? Bakit 6 sa 2p? So, ano ang reason behind that? So, in reality, 2s mas malapit sa nucleus. Yung 2p mas malayo sa nucleus. So, kung i-indicate po natin yung energy level, for example, ng 2s orbitals, and then yung 2p orbital, ganyan po siya. Mas mababa yung energy ng 2s kaysa sa 2p. But in reality po, meron tayong tatlong p orbitals at the second shell or second quantum number. So meron tayong 2p, 2p, 2p. Anong pinagkaiba ng mga yan? Magkakaiba lang po sila ng orientation in space. So, isang mahalagang rule po na dapat nating susundin is ang kada orbital ay kaya lang mag-occupy ng dalawang electrons. At ang dalawang electrons na ito ay merong opposite spin. So, 2s to 2p6. So, ang sabi dito, meron tayong 2 plus 6, 8 electrons na mag-occupy ng second shell. So, in this particular case, ganito po natin siya ipapopulate. So, 1, 2. So, yun yung 2s2. At this is a 2s orbital occupied by 2 electrons. And then 2p6. So, singly occupy muna po natin bago natin i-pair up yung electrons. So, ito po, tatlong 2p orbitals, each of which has 2 electrons. Kaya po ito ay 2p6. Okay, so klaro po ba? So ito po yung ibig sabihin nun. So napakahalaga po, pakitandaan po ito kasi itong electronic configuration na ito at yung orientation ng orbitals in terms of their energy levels, ganito po yung pagkakasunod-sunod niya. So again, pinakamababa ang 1s, then nasa second shell yung 2s at 2p, and between them, mas mababa ang energy ng 2s kaysa sa 2p. Pagdating sa third shell, or sa third quantum number, yung 3s ang mas mababa ang energy, at 3p yung mas mataas ang energy. So, tatandaan po natin ito. Okay, since na-review na natin yung electronic configuration, gawin na natin ang electronic configuration ng hydrogen at ng helium. Okay, hydrogen. Nagbilang tayo kanina. Ilan ang electrons na meron ang hydrogen? Hydrogen has 1 electron. So, kung isusulat natin yung electronic configuration niya, saan tayo magsisimula? Sa 1s. So, it's gonna be 1s, and then yung number ng electrons, 1. So, meron pa ba tayong electron na i-distribute? Wala na. And then, ano yung maximum occupancy ng 1s orbital dito? 2. So, ibig sabihin, sa 1s orbital, meron ka lang isang electron. Okay, tatandaan nyo yan. Now, when it comes to helium, helium has 2 electrons. So, 2 electrons, saan natin siya ilalagay? Ilalagay natin siya sa 1s orbital. So, 2 electrons as in the 1s orbital, it will look like this. So, 1, 2. Okay, so ang electronic configuration ng helium is 1s 2. So, ang tanong ko, meron pa ba tayong electron na pwedeng ilagdag? Wala na, kasi dalawa na nagamit na natin yung dalawang electrons ng helium. Ang tanong, anong pinagkaiba nito? So, itong 1s orbital ng helium is fully filled. So, it's completely filled. Hanggang dalawa lang ang pwede niyang i-occupy at meron siyang dalawang electrons. And this is the reason why helium is a very stable element. So, it doesn't form compounds. That is because, papakatandaan po natin ito, elements with completely filled orbitals are stable. And yung elements that have partially filled orbitals, they tend to form compounds kasi there is a reason. They would rather have a completely filled orbital. So it's either this might lose its electrons para wala na lang, para blanco na yung kanyang orbital, or it could gain another electron for it to have a stable, or for it to have like a completely filled 1s orbital for it to be stable. Gusto ng ibang mga elements maging kaparehas ng electronic configuration ng helium at ng noble gases. But again, tatandaan, stable ang isang elemento kapag ang kanyang mga orbitals ay completely filled. Okay, so pumunta naman po tayo sa medyo mas komplikadong example. So nandito gagawin natin ang electronic configuration ng fluorine, ng neon, at ng sodium. At ang assumption natin dito, these are all neutral elements. So, atin munang suriin. So, fluorine has an atomic number of 9. So, ibig sabihin, for a neutral atom, it should have 9 protons and 9 electrons. So, for fluorine, it has 9 electrons. For neon, it has an atomic number of 10. So therefore, for a neutral element, 10 protons and then 10 electrons. So 10 electrons for neon. Pagdating naman sa sodium, it has an atomic number of 11. Again, neutral element, 11 protons is equal to 11 electrons. So ito yung mga gagamitin natin bilang ng electrons, electronic configuration. So gawin naman natin ngayon ang electronic configuration ng fluorine. So gagawin natin 1s2 2s2. So ilan na nagamit natin dyan? 4. And then the next orbital that we will have to occupy will be the 2p orbital. Na ilan ang total occupancy ng 2p orbitals? It should have a maximum of 6 electrons. Again, kasi tatlong 2p orbitals. 2 electrons each. So ilan pa natitira nating electrons? So 9 minus 4 leaves us with 5 more electrons. So therefore, pwede pa natin siyang ilagay dito. So but tanong lang po sa inyo, na-occupy ba natin ng completely ang orbitals ng ang 2p orbitals ng fluorine? Ang sagot po ay hindi. So meron ka dyang vacancy kasi maximum niya is 6. Pagdating naman sa neon, this is how we're gonna do electronic configuration. So 1s2 2s2. So nakagamit na tayo ng 4 electrons. 4 minus 10 is equal to 6 electrons. So meron pa tayong 6 electrons na pwedeng ilagay. Ngayon, ang next orbital is a 2p orbital and it can occupy a total of 6 electrons. So therefore, ito, puno na siya. So this is a completely filled electronic configuration. Up until the second energy level, puno lahat ng electrons. Pagdating naman sa sodium, ang electronic configuration niya should be 1, S2, 2, S2, and then so 4 na yung nagamit natin, minus, so 11 minus 4 electrons, meron tayong excess of 7 electrons. Pero, doon sa 7 na yun, 6 lang yung pwede natin ilagay sa 2p orbital. So therefore, kailangan natin umakyat ng isa pang energy level, which is a 3s orbital, at doon natin ilalagay yung pang 11 na electron. Okay, ngayong natapos na natin ang electronic configuration ng fluorine, ng neon at ng sodium, meron tayong mga babalikang ilang mahahalagang konseptong pinag-usapan natin kanina sa case ng helium at saka ng hydrogen. So sabi ko kanina, ang electronic configuration of neon is very special kasi lahat ng orbitals involved are fully occupied. So for example, dun sa first energy level or quantum number na 1, where we only have one s orbital, fully occupied, dalawa. Doon naman sa second shell, we have the 2s and the 2p orbital. The second shell can occupy a total of 8 electrons. So in this case, how many electrons do you have? 2 plus 6 is equal to 8 electrons. So itong configuration na to is the reason why, like helium, neon is a very stable element. So it doesn't form any chemical bonds, it doesn't form any compound because it has completely filled orbital. And in this particular case, may dalawang mahalagang concept akong ituturo sa inyo. Ano ang tawag natin sa 1s orbital? So yung 1s orbital which is situated or which is contained within the first shell o yung mas mababang energy level or mas malapit siya sa nucleus ng neon, this is what we call a core orbital. So this is the core orbital. And inside the core orbitals are what we call the core electrons or the inner shell electrons. Ang tawag naman natin sa mga electrons na nasa highest energy level or nasa highest quantum number are what we call the valence electron. So yung valence electrons ay nakapaloob sa tinatawag nating valence orbitals. At gaya nga ng sinabi ng Lewis theory, elements form chemical bonds or they form compounds in order for them to have a stable configuration. And the stable configuration na sinasabi natin in this particular case would be a complete octet of electrons at the valence shell. So kailangan yung nandun sa valence shell ay merong 8 electrons. So completely filled ang 2s at ang 2p orbital. So kung ang valence shell naman natin nasa third quantum number, dapat yung 3s at 3p ay merong total of 8 electrons. So that is what we call the octet rule. In this particular case, sodium, may tendency siya na mag-form ng sodium plus ion. Kasi when you form sodium plus ion, that means it lost 1 electron. So pag nawala na tong electron na to, what you're left with is an electronic configuration for sodium plus ion, and kung mapapansin niyo, ang sodium plus ion has the same electronic configuration as neon, which is a stable configuration. Again, bakit? Because now its valence shell include the 2s and the 2p orbital na merong 8 electrons. So it's the octet rule. Pagdating naman sa fluorine, once it gains 1 electron, it becomes what we call the fluoride ion. So the fluoride ion gains 1 electron, and in the process, 5 plus 1, magiging 2p6 na to. So therefore, ang electronic configuration ng fluorine becomes equivalent to the electronic configuration of neon. So again, nagbabago ang bilang ng electrons dito sa mga elements na ito when they form compounds in order for them to achieve a complete octet. Kasi again, pag may octet, stable. So again, idol ng fluorine at saka ng sodium ang neon. So therefore, kokopyahin nila sila by either accepting an electron or by donating 1 electron. Okay, so pasadahan naman po natin itong mga examples na ito na binigay dun sa ating question. So, ibibigay natin na electronic configuration ng boron, ng carbon, nitrogen, oxygen, fluorine, and neon. So, mabilisan lang po ito. Ano po?
Okay, so boron, atomic number of 5. Kung neutral, 5 electrons. So, ang electronic configuration will be 1. Kung sumusulat sana ang aking marker ay 1, S2, 2, S2. So, meron na tayong 4 electrons. Isa na lang natitira. So, therefore, this is going to be 2p, 1. Okay, so pagdating sa carbon, it has 6 electrons. It's 1, S2, 2, S2, 2p. So, ibig sabihin, meron pa tayong natitira ng electrons, 2p, 2. Pagdating sa nitrogen, it's going to be 1, S2, 2, S2, 2p, 3. Okay, pagdating naman sa oxygen, it will be 1, S2, 2, S2, 2p, 4. Sa chlorine, 1, S2, 2, S2, nawala natin pa kanina 2p, 5. Ang pagdating naman sa neon, 1, S2, 2, S2, 2p, 6.
So, ang tanong naman po sa atin ngayon is, or isulat daw po natin ang Lewis symbol for these elements. So, ano ba ang sabi dun sa Lewis symbols? Dapat isusulat natin yung symbol for the element, and then we will populate it with the number of valence electrons. Yung orbitals na nasa may pinakamataas or na may pinakamataas na quantum number or yung numerical coefficient, yun ang tinatawag natin na valence shell. So, nandun yung valence orbitals. At kung nasan yung valence orbitals, na andun ang ating valence electrons. So, in this particular case, ang ating core orbital will be the 1s orbital. Ang ating valence orbitals will be the 2s and the 2p orbital. So, ilan ang electrons sa 2s at 2p orbital pag pinagsama? So, 2 plus 1 is equal to 3.
Pagdating naman sa carbon, core orbital ng 1 is valence orbitals ng 2s at 2p. So, meron tayong 2 plus 2 electrons equals 4 electrons. In the case of nitrogen, again, valence orbitals, 2 plus 3 is equal to 5. In the case of oxygen, 2 plus 4 is equal to 6. In the case of chlorine, 2 plus 5 is equal to 7. In the case of neon, 2 plus 6 is equal to 8.
So, ang sabi, ang Lewis symbol, kailangan natin isulat yung symbol muna ng element. So, we have boron here. We have carbon. We have nitrogen, oxygen, fluorine, and neon. And then what we need to do is to write or represent the valence electrons in the form of dots. So, ilan ang valence electrons ng boron? 3. So, we will draw the electrons around boron. So, 3. So, hindi ko muna siya pinagpapares-pares, and that is for a reason. So, whenever you try to decorate your elemental symbol with the number of valence electrons, bago po kayo magpares-pares, paghiwa-hiwalay nyo muna sila. Gusto nila yung mga nag-iisa muna sila. Ayaw maganda na lang may kasama. Pagdating sa carbon, 4 yung valence electrons. So 1, 2, 3, 4. Pagdating sa nitrogen, it has 5. So hiwa-hiwalay muna. 1, 2, 3, 4. And then after that, pwede na po kayo magpares-pares. So, bakit ba natin pinagpapares after 4? So, kung mapapansin nyo sa carbon, pinaghiwa-hiwalay natin yung 4 na electrons kasi in essence, meron tayong 3p orbital sa valence shell at merong isang s orbital. So, meron tayong in total na 4 na orbital sa pwedeng pag-distribute ng electrons when they form compounds. So, ganoon lang po yun. Hindi muna natin lalaliman yung pagpapaliwanag. Sundin nyo na lang muna po itong method na ito. Pagdating naman po sa oxygen, meron tayong 6 valence electrons. So, 1, 2, 3, 4. So, 4 yung magkakahiwalay. Ngayon, wala na tayong choice. Meron pa tayong dalawa. So, kailangan na natin magpares-pares. 1, 2. Pagdating naman sa fluorine,
1, 2, 3, 4. Magpapaya pa tayo. 5, 6, 7. Pagdating sa neon, 1, 2, 3, 4. Magpapares tayo. 5, 6, 7, 8.
so kung mapapansin ninyo, ang neon already has 8 electrons around it. And as we said, it's stable because it already has a complete octet. symbol ng fluorine, 3 pairs of electrons at isang unpaired electron. Pagdating sa oxygen, meron siyang dalawang electron pairs, dalawa siyang electron pairs, meron dalawang unpaired electrons. Pagdating sa nitrogen, meron siyang isang electron pair at 3 unpaired electron. Pagdating sa carbon, meron siyang 4 na unpaired electron. Pagdating sa boron, meron siyang 3 unpaired electron. Yung number ng paired at unpaired electrons around these elements will have consequences mamaya when it comes to discussions of covalent bonding. So, ilan ba yung total number or maximum number na covalent bonds na pwedeng ma-form ng mga elementong ito? Ito po, ang Lewis symbol ng boron, carbon, nitrogen, oxygen, fluorine, at ng neon. With neon having a stable configuration, kita nyo naman, 8 ang electron sa paligid niya. It has a complete octet of electrons. So, siya yung idol ng lahat ng mga elementong ito.
Okay, ngayong nagawa na natin ang pagsusulat ng Lewis symbols, gamitin naman natin ang Lewis symbol sa pagsusulat or sa pagdraw ng Lewis structures. So gaya ng sinabi natin kanina, merong dalawang klase ng chemical bonding na pwede nating i-represent via Lewis structure. So ang una na dito ay ang ionic bonding or ang formation ng ionic compound. So an ionic bond forms from the transfer of electrons from one atom to another. So in the process of the electron transfer, the resulting positively charged ion and the resulting negatively charged ions will both have a stable electronic configuration. So typically, nasa-satisfy nila yung complete octet. So ngayon, medyo hindi po to straightforward. Baka malito yung mga bata sa atin. Kailan ba ionic yung bond? Or kailan ba nagpo-form ng ionic compound? Kailan ba nagpo-form ng covalent compound? So, yung isa pong trick na pwede po nating ituro sa mga bata is kapag ang isang metallic element ay nag-combine with a non-metal, typically they form an ionic compound, or there is an ionic bond forming between the two of them. So for example po, sodium chloride is one of the most typical examples that we use in our classroom. So sodium is a group 1 metal and chlorine is a non-metal. It's in the halogen group. So when they combine, so when sodium and chlorine combine to form sodium chloride, they form an ionic bond. So baka po may magtanong sa inyo, bakit hindi natin ginagamit yung electronegativity differences, yung ika-calculate, po. So medyo I'm opposed to just like using mathematical formula para po i-define itong mga bagay na ito. So I would rather give you an overview of like the key concept. So ano ba yung types ng elements na nagpo-form ng ionic bonds. So, metals plus non-metals, they form ionic bonds. In certain cases, metalloids combined with non-metals. For example, aluminum plus chlorine, they form aluminum chloride, which is also fairly ionic in nature. So, yun po. So, magbibigay po tayo ng ilang mga examples para ipakita sa inyo sa kung paano ba natin gagamitin muli ang Lewis symbols sa pagdraw ng Lewis structures of ionic compounds. How we can use Lewis symbols to demonstrate how ionic bonding occurs.
So ngayon naman po, kailangan nating ibigay ang Lewis structure ng sodium chloride. So unang-una, ano bang klase ng compound ang sodium chloride? So whenever we are given a compound that is composed of a metal and a non-metal, that is typically what we consider an ionic compound or they form salts. So in this particular case, how does that happen? So mas maiintindihan po natin yung nature ng ionic bond kapag ginawa natin ang Lewis structure ng sodium chloride, and in the process, titingnan natin ang electronic configuration niya. Okay, so ano ba ang mga elementang bumubuo sa sodium chloride? So it is composed of the elements sodium and chlorine. So ang una po natin gagawin muna is tingnan ang electronic configuration ng sodium at ng chlorine in their neutral state. So una, sodium has an atomic number of 11. So that means for a neutral sodium element, it has 11 protons and 11 electrons. So isusulat natin yan. 11 electrons. Chlorine has an atomic number of 17, so that means it should have 17 protons and 17 electrons. Sulat din natin para hindi natin makalimutan. And then what we'll have to do is we will have to write the the electronic configuration of these elements. So in the
case of sodium, 11 electrons ay distribute natin sa iba't ibang orbitals. So mag-start tayo sa 1s2, 2s2, 2p6. So that means na meron na tayo 10 electrons. So we have an excess of 1 and that will end up at the, or placed in the 3s orbital. So ito po ang electronic configuration ng sodium. At kung susunod po natin, ang 1s hanggang sa 2s orbitals, ito ang tinatawag natin na orbitals. Ito naman 3s, ito ang tinatawag natin na valence orbital.
Alright. Pag tinanong ko yun, ilan ang valence electrons ng sodium? Meron siyang isang valence electron. Now, we move on to chlorine. Ang electronic configuration naman po ng chlorine will be
1s2, 2s2, 2p6. So pagkatapos dito, meron na tayong 10 electrons, minus 17, meron pa tayong 7 na i-distribute. Ano kasi na orbital ito? 3s. So we're gonna put 2 there kasi it can be occupied by a maximum of 2 electrons. So 17 minus 12, ibig sabihin, pagdating sa 3p orbitals, this will have 5 electrons.
Okay, so ngayon naman, sabihin natin yung electronic configuration na ibinigay. So sabi dito, ang core electrons ng sodium ay nasa 1s hanggang 2s and 2p orbitals from the first hanggang sa second energy level. Pagdating naman sa third energy level, ito ang tinatawag nating valence orbitals. Tama po, yung may pinakamataas sa quantum number or coefficient before the orbital. Pagdating naman sa chlorine, ganun din. Ang ating core orbitals ay nasa 1s, 2s at 2p. Pagdating naman sa pinakamataas na energy level, yung 3s at 3p orbitals, ito ang tinatawag natin na valence shell. So, nandyan yung ating valence orbitals. And when it comes to forming chemical bonds, and in particular, ionic bonds, ang nagbabago lang po or ang electrons na nata-transfer ay yung mga nasa valence orbital. So, paano ba? Ano bang nangyayari dito? So, kung titingnan po ninyo, itong electronic configuration na to, 1s2, 2s2, 2p6, this is isoelectronic with the element, what? With the element neon. So in order for it to have a stable configuration, all that sodium has to do is to lose this electron. Kailangan lang niyang mawala yung electron na yun, and then it becomes stable already. So bakit stable? Kasi when it comes to neon, kapag nawala na ang kanyang electron, mawawala na yung 3s orbital or hindi na siya occupied, hindi na occupied yung 3s orbital. So ang magiging valence orbital mo na dyan is yung 2s at saka 2p orbitals, which has a total of 8 electrons. So therefore, if sodium loses an electron in the process to form a sodium plus ion, nagiging stable siya. Kasi sodium plus ion is isoelectronic with the element neon. So ito po yung responsible for the formation of a sodium cation. Okay, wag niyo po yung kakalimutan. Ano po? Okay, so bubarahin ko muna yan. So, sodium ionizes and it loses 1 electron to form a sodium plus cation. So nawawala na po ito. So yung resulting ion nyo during the process will be a sodium plus ion. Okay. Pagdating naman sa chlorine, 1s2, 2s2, 2p6, 3s2, 3p5. Okay. Ano yung pinakamadaling pwedeng gawin ng chlorine for it to have a complete octet of electron? Pwede ba siyang mag-lose ng 7 electrons? So technically, hindi po niya kaya yun kasi it requires so much energy para maka-lose siya ng 7 electrons. And yung mas convenient sa kanila, medyo tamad din po kasi itong mga elements na ito, yung pinakamadali yung gagawin niya. So sa halip na mag-lose siya ng 7 electrons, ang gagawin niya na lang, mag-aagaw siya ng or mag-a-accept siya ng isang electron. So kapag po nag-gain siya ng 1 electron during the process, this becomes 3p6. And this electronic configuration is now isoelectronic with the element argon. So chlorine needs to gain 1 electron for it to have a stable configuration similar to argon. And in the process, yung pong kanyang valence shell has a total of 8 electrons. Again, a complete octet. So in the process, chlorine gains an electron to form a chloride ion. Okay, so paano ba natin ipapakita itong prosesong ito in the form of Lewis symbol? So dito na po papasok yung ating pagsulat ng symbol. So tatandaan niyo po yung pagbibilang natin ng electrons ng valence electrons, ano po. So sodium has one valence electron, nasa 3s1. So sodium, ang lowest symbol po niya is a sodium center with 1 electron. Okay, nakikita niyo po ba yan? Pagdating naman sa chlorine, chlorine has 7 valence electrons. So, ito po ang lowest symbol niya. Meron siyang 3 paired electrons at meron siyang isang unpaired electron. So, what happens is, for chlorine to have a complete octet of electrons, itong isang electron na ito ng sodium is mata-transfer to chlorine. And ang resulting lowest symbol po natin dyan will be sodium. Kailangan po natin i-indicate na siya ay ionized, siya ay may +1 oxidation state. And then, wala na siyang dots kasi nawala na yung kanyang valence electrons. Isa lang naman na valence electron niya yung nasa 3s. And then, chlorine will have a total of 8 electrons around it. So again, this chloride ion is isoelectronic with the element argon. The sodium plus ion is isoelectronic with the element neon.
Narito naman ang isang graphic representation ng ginawa nating gamit ng Lewis symbols para ma-form ang sodium chloride from a neutral sodium atom and a neutral chlorine atom. So gaya na ipinakita natin kanina sa electronic configuration, ang valence electrons ng sodium ay nasa third shell. So yung 3s1 orbital natin may isang unpaired electron. Pagdating naman sa chlorine, ang kanyang valence orbitals ay nasa third shell din at meron siyang 7 electrons doon. So, the 3 paired electrons at isang unpaired. So, what happens is, yung electron sa 3s1 orbital ng sodium ay nata-transfer into the third shell of the chlorine atom. And in the process, you form a sodium cation which now has its valence electrons at the second level or second shell. So, dun sa second shell, kung bibilangan ninyo, meron din kayong 8 electrons doon sa outer shell. So this makes it stable. This is isoelectronic with the element neon. Pagdating naman sa chloride, upon forming an anion, nakukumpleto ang 8 electrons required para maging stable yung valence shell at quantum level number 3 or nasa third shell. So this is how atoms combine to form a chemical bond for the 2 atoms to gain or to achieve a stable electronic configuration. Again, this is ionic bonding. So, magsasagot naman tayo ng mga karagdagang examples.
Okay, kasunod na example naman po tayo. Magnesium oxide naman po ang gagawa natin ng Lewis structure. So this is another ionic compound. So there's an ionic bond between magnesium and oxygen or oxide ions in this process. So paano ba natin ito i-demonstrate using Lewis symbols and Lewis structure? So again, gagawin natin electronic configurations ng magnesium and ng oxygen. So dito, binigyan na po natin yung atomic numbers nila. So 12 for magnesium and then atomic number of 8 for oxygen.
So, electronic configuration. So, dapat medyo mabilis na ito. Dapat expert na tayo sa mga examples na tayo. So, magnesium, 12 electrons. So, 1s2, 2s2, 2p6, 3s. So, yan ito. 6 plus 2 plus 2 is equal to 10. 12 minus 10 is equal to 2. So, dapat meron siya 2 electrons sa 3s orbital.
So, ang kanyang 3p orbitals ay walang electron. So, therefore, sa kanyang valence shell, wala siyang complete octet. So, hindi pa rin siya stable. Kasi baka sabihin nyo, ay, kompleto na po yung S. Pero yung p orbitals nyo kasi is bakante. So, therefore, yung third shell, wala siyang complete octet. Again, unstable. So, it will tend to form or to either gain more electrons or lose more electrons.
Pagdating naman sa oxygen, it has an atomic number of 8. Neutron element, 8 electrons. So, 1s2, 2s2. So, nakagamit tayo ng 4. 8 minus 4 is equal to 4. So, we have to put 4 electrons in the 2p orbital. So, in this particular case, ating orbital ay nasa 1s. Ating valence orbital, ating valence shell ay nandun yung 2s at yung 2p. Kung kasamahan yung electrons, meron tayong 6 electrons. So, hindi pa siya stable. Dapat octet mo. So,
Paano ba to? So, in the case of magnesium, paano ba siya makaka-achieve ng complete octet? So, ano mas madaling gawin? Sabi ko sa inyo, itong mga elements na to, parang ako lang nung high school. Mga tamad. So, ito kasi in order for the third shell to have a complete octet of electrons, dapat makagain siya ng 6 electrons. Masyadong matrabaho yun. 6 na steps, ayaw natin yan. So tamad tayo. So sa halip na mag-gain ka ng 6 electrons, ang gagawin mo, maglo-lose ka, idodonate mo na lang ito. Diba? Sa napakabait mo. Magnesium mabait, namimigay siya ng electrons, 2 electrons. So upon doing so when magnesium loses 2 electrons, what forms is a magnesium 2 plus ion. So, electron counting lang tayo, ano po? Okay. Pagdating naman sa oxygen, para magkaroon siya ng complete octet dito sa valence shell, ano ba yung mas madali? Mag-lose siya ng 6 na electrons or mang-agaw or kumuha na lang siya ng 2 dagdag na electrons. So, in this particular case, you need just like 2 extra electrons for this to be a complete octet. So 2s2 plus and 2p6. So, octet na of electrons na yun. So, tamang-tama naman, no? So, perfect match sila. Kasi yung bilang ng electrons na dapat nitong ipamigay ay sakto sa bilang ng electrons na dapat itong matanggap. So, in that process, yung oxygen, as it gains 2 electrons, it forms an oxide ion. So, O2 minus. So, this is a cation since it's positively charged. This is an anion because this is negatively charged. So, yun. Kailangan natin pakita paano pa nagpo-form yung ionic bond in the form of Lewis symbols and eventually Lewis structure. So magnesium, susulat nyo lang yung symbol niya. Magnesium has how many valence electrons? So tanggalin natin to kasi baka marito kayo. It has 2 valence electrons. So ilalagay natin yun dyan. 1, 2. How about oxygen? Oxygen has how many valence electrons? Yung valence electrons nasa 2s at nasa 2p orbital. So yung oxygen has a total of 6. So 1, 2, 3, 4, 5, 6. So, ito kailangan niya mag-lose ng electron para maging stable siya. Ito kailangan niya mag-gain ng electron para maging stable siya. So, therefore, itong electron na to could get transferred to oxygen to pair up with this electron. Itong electron na to will also get transferred to oxygen to pair up with this electron. You form a magnesium 2 plus ion and then an oxide, an ion. Okay? So yung magnesium 2 plus cation ninyo, this is isoelectronic with the element, what? Hulaan nyo? Neon. So this is isoelectronic with neon. This oxide ion is also isoelectronic with neon. So therefore, stable na sila kasi meron silang parehas na complete octet in their resulting valence shell. So ang huli po natin example yung medyo pinakamahirap kasi this involves aluminum oxide. So Al2O3. So binayapas ko na yung electronic configuration. Dumiretso na po ako sa Lewis symbols for each element comprising aluminum oxide in their neutral form para makita po natin yung transfer ng electrons. So in the case of aluminum po, it needs to lose 3 electrons for it to become isoelectronic with the element neon. In the case naman of oxygen po, it needs to gain 2 electrons for it to become isoelectronic with the element neon as well. So, ito, ang kada oxygen atom, sabi nga po natin, kailangan mag-gain ng 2. So, simulan natin. Itong unang electron na to, i-donate natin dito to form an electron pair. Itong pangalawang to, i-donate natin dito. So, in this process, you will form an oxide ion. Okay. Dito sa electron transfer na to, meron pang sobrang isang electron doon. Okay, so yung electron na yan, pwede mong i-donate dito sa pangalawang oxygen atom. And then, in the process, 7 na yung electron niya. So, kailangan pa niya ng isa for it to have an octet of electrons. So, dun siya kukuha sa pangalawang aluminum. So, in this process, in total, 1, 2, 3, 4, 4 na electrons ang ating na-transfer from aluminum to the oxygen atoms. You are going to form another oxide ion here. Okay, now, ilan na lang yung natitira? Meron ka na lang 2 free electrons sa aluminum na pwede mong i-donate doon sa pangatlong oxygen atom. So in this process, you will form another oxide ion. So in this process, you form 2 aluminum 3 plus ion, and then 3 oxide ion. So ito po ang Lewis symbol na ating pwedeng gamitin to represent aluminum oxide. So again, there's a net transfer of 3 electrons, of 6 electrons from 2 aluminum atoms to 3 oxygen atoms to form 3 oxide ions.
Okay, dadako naman tayo sa paggamit ng Lewis symbol sa pag-draw ng Lewis structures ng covalent compounds. But bago ulit tayo mag-solve ng problems, balikan muna natin, ano nga ba ang covalent bonding? So covalent bonding is the type of chemical bond that forms when 2 atoms share electrons. So covalent compounds are compounds formed via the sharing of electrons between atoms. So, ang isa pong tip na maibibigay ko sa inyo, ang covalent compounds naman po, nagpo-form sila whenever you are combining 2 non-metallic species. So, for example, pag pinag-combine po ninyo ang carbon at hydrogen to make methane o CH4, that forms a covalent compound. Kapag pinag-combine nyo po ang hydrogen at oxygen to form water, ang oxygen at hydrogen po ay parehas non-metallic. So therefore, they will form a covalent compound. Kapag pinag-combine niyo ang nitrogen at hydrogen to form ammonia, ang nitrogen at hydrogen, both are non-metallic, they will form a covalent compound. So yun po ang tip na ating papakatandaan. Ngayon, magsagot na tayo ng mga halimbawa. So una, isulat or i-draw ang Lewis structure para sa hydrogen gamit ang Lewis symbols. Gawin din ito in the case of a chlorine molecule. At panghuli, isulat ang Lewis structure ng hydrochloric acid.
Okay, so we just tackled the textbook definition of a covalent bond. Pero ito po tip sa mga teachers. Kapag i-introduce po natin itong topic na to, you just start with some of the most basic examples. So, what I mean with basic would be diatomic molecules. So, simulan natin sa case ng hydrogen molecules. Ano ba meron sa hydrogen? So, it has 2 hydrogen atoms. At ano nga ba uli ang atomic number ng oxygen? It has an atomic number of 1. Meaning, in a neutral hydrogen atom, it has 1 electron, and its electronic configuration should be equal to 1s1. So, ang gagawin muna natin is ating isulat ang Lewis symbol ng dalawang hydrogen atom. Okay. Gusto ko pong tingnan ninyo ang valence. So ang hydrogen is very special because it only has one orbital, which is the 1s orbital. And at the moment, for a neutral hydrogen atom, it has like 1 electron. So it's unpaired. Kasi ang stable configuration ng isang hydrogen atom should be equivalent to that of helium. So magiging stable lang po ang hydrogen kapag ang 1s orbital ay merong maximum occupancy of 2 electrons. So again, isoelectronic with helium. So you are combining 2 hydrogen atoms in the process. So wala kang metal na magdodonate, wala kang element na mag-form ng cation at magdodonate ng electron. Instead of 1 hydrogen atom transferring 1 electron to another hydrogen atom, what they do is they share this electron. Kung i-rewrite po natin yan, there is an electron pair being shared by the 2 hydrogen atoms. This pair of electrons is what we call a covalent bond. And whenever we are writing Lewis structures or Lewis symbols, 1 covalent bond is equal to 2 electrons, or this is what we call a bonding pair. So we can rewrite this in this form. So hydrogen having a single bond with another hydrogen atom. So the question is, can it form another bond? No. Okay, kasi kailangan lang talagang mapuno ng oxygen yung 1s orbital. And so, since pag nag-share siya ng electrons, yung 1s orbital nito is already sharing 2 electrons with the other. So, stable na siya. And one very important rule po sa pagsulat ng Lewis structure, hydrogen can only have one bond. It can only form a maximum of 1 covalent bond. Kapag po ang hydrogen na ginawa na pag-structure po ng compound na sinulat ng estudyante nyo ay merong 2 o 3 bonds around hydrogen, pwede nyo na po silang i-nominate sa Nobel Prize kasi hindi po yun pwede. Impossible po yun. Ano po? Okay, so ang pangalawa naman po natin example is a Cl2 molecule or a diatomic chlorine molecule. So Cl2, it is composed of 2 chlorine atoms. So bakit ba napo-form tong compound na to? So that can be explained by its Lewis structure. So again, since nagawa na natin example kanina yung chlorine. Chlorine has 7 valence electrons around it. And in order for it to become stable, sabi nga po natin, kailangan niya mag-gain ng isang electron. So you're combining atoms of the same element. So wala kang driving force para mag-lose to ng electron at donate dito sa kabila kasi chlorine does not form a stable cation. What happens is, since meron kang isang unpaired electron sa kada chlorine atom, these electrons would be shared by the 2 chlorine atoms. So in the process, you form, or you share, since you share an electron pair, you form a covalent bond. So that covalent bond is comprised of 2 electrons shared between or shared by the 2 chlorine atoms. So ito ang Lewis dot symbol for a chlorine molecule. So magbilang tayo ng electrons around each chlorine atom. So for this chlorine atom, it has 1, 2, 3, 4, 5, 6, 7, and 8. So meron kang 8 electrons around the first chlorine atom. How about for the second one? You have 1, 2, 3, 4, 5, 6, 7, and 8. So it also has 8 electrons around it. So by sharing 1 electron to form a chlorine-chlorine covalent bond, you are forming a Cl2 molecule or a chlorine molecule where each chlorine atom has an octet of electrons. So okay, this is a neutral molecule. Sinishare yung electron between the 2 chlorine atoms. So same driving force po. So same reason why chlorine is forming this, in this case, a covalent bond. It needs to gain or to achieve or to have a complete octet of electrons. So iba lang po yung mechanism ng pag-form ng bond. So in the case of sodium chloride, sodium donates an electron to chlorine to form a chloride ion. So that way, wala din yung electrons around it. In this case po, since sharing ng electron, ang kailangan lang natin tandaan is the bond between them is equally shared.
Narito naman ang graphical representation ng pag-form ng covalent bond sa pagitan ng 2 chlorine atoms. So kung makikita ninyo sa left side, meron tayong 2 neutral chlorine atoms na merong 7 electrons sa kanyang third shell. So kung mapapansin din ninyo, sa third shell, meron silang tig-isang unpaired electron. And so, by combining or by sharing these unpaired electrons and by forming a covalent bond, what forms is a diatomic chlorine molecule where both chlorine atoms achieve a complete octet of electrons. So, yan po medyo straightforward siya. So, huwag kakalimutan ng ating electronic configuration at ang pagbibilang ng valence electrons. Again, yung valence electrons ang nagde-dictate ng mechanism or mode of chemical bonding.
Okay, so ang third example po natin is hydrochloric acid or a hydrochloric acid molecule, so HCl. So paano ba nagpo-form yung bond dito? Is this a covalent or an ionic compound? So nakapumalito yung mga estudyante, kasi yung hydrogen is in the same group as our group 1 metals. However, hydrogen is not a metallic element. So it tends to form covalent bonds unless it is combined with group 1 elements. So for example, sodium hydride. So in that particular case, it's an ionic compound. But when hydrogen is combined with another nonmetal, they tend to form covalent compound. So nakita ko po ang Lewis symbol ng hydrogen at ang Lewis symbol of a neutral chlorine atom. So ang sabi nga po natin, hydrogen can only form one bond because it only has like one orbital, which is the 1s orbital. And in the case of chlorine, it needs to gain, or it needs to be able to complete its octet of electron. So in this particular example, these unpaired electrons will come together to form a covalent bond. So in this this electron pair will be shared between hydrogen and chlorine. So ito po ang Lewis dot symbol for hydrochloric acid. Sabay lang po tayo. So ilan yung number ng electrons dapat around the hydrogen for it to be stable? Sabi natin 2. So magbilang tayo. 1, 2. So in the case of chlorine, ilan dapat ang electrons around it for it to be stable? It should have a complete octet. So 1, 2, 3, 4, 5, 6, 7, 8. So kapag ipinasulat po sa atin ang Lewis structure ng hydrochloric acid, it should actually look like this. So hydrogen having a single bond with a chlorine atom, and the chlorine atom should actually have 6 electrons around it, or 3 lone pairs around it. So these are like non-bonding pairs. So nandun lang sila sa paligid ng chlorine. Okay, so klaro po, ano po. So again, tatandaan natin, 1 covalent bond is equal to 2 electrons. There are some systems out there, or some molecules out there, where in order for us to complete the octet of one of the atoms, they need to form multiple bonds. So minsan merong double covalent bond, merong triple covalent bond. So yun yung gagawin natin sa mga susunod na example.
Okay, so kakapakita lang po natin kung paano ba ang paggamit ng Lewis symbols para mag-draw ng Lewis structures ng simple diatomic covalent compound. So ngayon, medyo isa-stretch po natin ang ating grasp ng Lewis theory at ng Lewis structures. So kung paano po ba natin i-draw ang chemical or i-describe ang chemical bonding sa mga compounds na mas marami sa dalawa ang atoms na bumubuo dito. Okay, pero bago po tayo pumunta dyan, kailangan muna nating pasadahan ano ba yung mga mahahalagang strategies pagdating sa pagsulat ng Lewis structures ng polyatomic molecules. So unang-una, gaya na sinabi ko kanina, all valence electrons of the atoms in a Lewis structure must appear in the structure. So, ibig sabihin po, magbibilang tayo lagi ng valence electrons. At kung ilan yung bilang ng valence electrons from the atoms involved in or present in the compound, dapat makita po natin lahat ng electrons na yon sa Lewis structure. So, secondly, this is a very important rule. So, usually, all the electrons in the Lewis structures are paired. Okay? Most compounds, when they form, they tend to pair up all of their electrons. So kapag nakakita po kayo ng unpaired electron, typically that's a red flag kasi that's a signal or that's an indication that that structure is a non-stable structure. So ang nature, hindi niya i-favor na mag-form yung ganong structure kung merong naiiwang electron na walang kapares. So pangatlo po, usually each atom acquires an outer shell octet of electrons. So, you know, in the exception of hydrogen, lahat po ng mga elements na may encounter natin when it comes to covalent bonds, they tend, or the resulting configuration of all the atoms in the covalent compound will have an octet of electrons. And pangatlo po, sometimes, kapag po nabuo na ninyo yung initial structure or arrangement ng mga elements or atoms in space to form the compound, minsan ang connectivity po ng mga atoms na ito could be achieved via single covalent bonds, pero meron din po mga elemento na kaya mag-form ng multiple covalent bonds. So pwede po tayo magkaroon ng double bonds, pwede po tayo magkaroon ng triple bonds. At narito po ang ilan sa mga examples ng mga elemento na kaya mag-form ng multiple bonds. So, nandyan ang carbon, nandyan ang nitrogen, nandyan ang oxygen, phosphorus, at ang sulfur atom. So, papakatandaan po natin ito sa pag-solve natin ng mga susunod na questions. Bilang paghahanda po sa pagsulat or pag-draw ng Lewis structures ng mga mas komplikadong covalent compounds, narito po ang isa sa mga unang hakbang na dapat din nating gawin. So, unang-una, kailangan marunong tayong sulat or mag-draw ng plausible skeletal structure. So, pag sinabi po natin plausible skeletal structure, ito po yung pagkakasunod-sunod or yung orientation in space ng lahat ng atoms na bumubuo sa isang covalent compound. At ilan po ba ang klase ng atom sa isang covalent compound? Meron tayong dalawang klase ng atom sa covalent compound. The first is the central atom or yung central atom kung saan nakakonekta ang karamihan sa iba't ibang mga atoms na bumubuo ng covalent molecule. Ang pangalawa naman po ay ang terminal atom. So, ang terminal atoms, ito lang po yung mga atoms na nasa gilid. So, for example, sinabi natin kanina, ang hydrogen can only form a maximum of 1 covalent bond. So, ibig sabihin po noon, ang hydrogen atom ay laging nasa mga gilid-gilid. Sila lang ang nakapaligid sa mga central atoms. So, gaya nga ng nabanggit ko kanina, ilan sa mga bagay na dapat tandaan, ang hydrogen atom ay palaging terminal atom dahil isa lang ang maximum number ng bond na pwede nilang ma-form. Ang pangalawa, central atoms are generally those with the lowest electronegativity. So, ang electronegativity po ay ang property ng isang element to attract electron towards it. So kung ikukumpara po natin ang mga elements na nasa parehas na period. So, dun sa hilera ng boron, carbon, nitrogen, oxygen, fluorine. So, as you move to the left of the periodic table, pataas po ang electronegativity ng mga elements na ito. So, ibig sabihin, ang fluorine ay mas electronegative in comparison to nitrogen. So, kung magpo-form ng compound ng covalent bond between nitrogen and fluorine atoms, magiging central atom ang nitrogen. So, that is how that works. So, electronegativity is key. So, pangatlo po, whenever carbon forms a covalent molecular compound, carbon is always a central atom. So, pakatatandaan po natin ito. And then lastly, molecules and polyatomic ions generally have compact and symmetrical structures. So, kung halimbawa, meron po tayong compound na mayroong 10 elements, sa halip na gumawa tayo ng napakahaba na linear molecule, ang tendency po is to come up with the most compact structure. Medyo mahirap pong i-explain itong pang-apat na guideline. So makikita po natin ito mamaya sa isang example na gagawin natin sa dulo. Okay, so wag po natin kakalimutan ang guidelines na ito. Okay, ngayon naman, sulatin natin ang Lewis structures ng methane, ammonia, at water.
Challenge namin kayo, dadamihan naman natin yung ganap. So, ang kailangan po natin gawin is we have to draw the Lewis structures of these molecules, all covalent compounds. Methane, CH4, ammonia, NH3, and water. Okay. Po, mahalaga uli, maisulat natin yung Lewis symbols muna no elements that comprise each molecule. So in the case of carbon, okay, hindi na po muna natin babalikan ang kanya electronic configuration kasi nagawa na natin to kanina. So sabi natin merong 4 na unpaired electrons around carbon. And then now, meron naman tayong ilang hydrogen. So meron po tayong 4 na hydrogen atom. So each hydrogen atom will have an unpaired electron. Right? So, ang mangyayari po dito, since carbon and hydrogen are both non-metal, so ibig sabihin, nagpo-form sila ng covalent bond. So, itong electron na ito ng hydrogen will be shared, or itong dalawang electrons na ito will be shared between carbon and hydrogen. Same as this pair, same as that pair, and same as that pairs. And we know during this process, so carbon will end up having 8 electrons around it, and each electron pair is shared with hydrogen. So ngayon, ang tanong, does this satisfy the requirements of the Lewis theory for both carbon and hydrogen to be stable? So ano ba requirement for hydrogen? Sabi natin for hydrogen, for it to be stable, it has to have 2 electrons around it. So this hydrogen has 2 electrons. This one also has 2. the same as this one and this one. So it satisfies the requirements for hydrogen. Now, in the case of carbon, for carbon to be stable, it needs to have 8 electrons around it for it to be isoelectronic with the element neon. So bilangin natin, 1, 2, 3, 4, 5, 6, 7, 8. So therefore, this satisfies the octet rule or the octet requirement for carbon. So kung susulatin po natin yung Lewis structure of methane, this will be carbon having 4 single bonds around it, and each single bond is connecting carbon with hydrogen. Again, each covalent bond is called a bonding pair. Tatandaan po natin ito, no? Bonding pair. Ngayon, ang tanong, meron bang lone pair? Meron bang pairs of electrons around carbon na hindi nakabond sa ibang elements? So, wala. Tatandaan natin yan. So, methane has 4 bonding pairs. So in the case of ammonia, the nitrogen center has a total of 5 valence electrons. So one pair of electrons, and then 3 unpaired electrons, and then yung ammonia has 3 hydrogen centers. So kailangan din natin i-account yun. So hydrogen, meron tayong 3. And each neutral hydrogen atom should have or should come with 1 unpaired electron. So similar to what we did earlier, we have to figure out a way to share or to combine these elements to satisfy their electronic requirements for them to be stable. So dapat yung hydrogen will end up having 2 electrons around it. And then also the nitrogen should have an octet of electrons. So in this process, these electrons will pair up, these will pair up, and also these will pair up. And in the process, what you will get is a structure where nitrogen has 8 electrons around it, satisfying the octet requirement. And then 3 of these electron pairs are shared with 3 hydrogen atoms. So kung susulatin naman natin ang Lewis structure ng ammonia, it will look like this. So 3 nitrogen-hydrogen single bond or covalent bond, and then a lone pair. In this case, we call this, again, ang sabi natin kanina, a bonding pair. And this is what we call a lone pair. So ang lone pair po, it occupies space around the atom. Similar to nitrogen-hydrogen covalent bond, it also occupies space. So tatandaan po natin yan. So ammonia has 3 bonding pairs, and it has like 1 lone pair. So our third example is water. So kailangan muna natin isulat yung Lewis symbol for oxygen. So oxygen has 6 electrons around it, 2 unpaired electrons and 2 paired electrons. And sabi natin, meron tayong 2 hydrogen atoms, each of which has 1 unpaired electron. And for us to be able to form the structure and to satisfy the requirements for hydrogen and oxygen to be stable, what we can do is that, we can pair up these unpaired electrons. So in the process, you will get a structure where oxygen has 8 electrons around it, again satisfying the octet rule, and then each hydrogen atom is sharing a pair of electrons with the oxygen center. So dalawa ang electrons around each hydrogen atom. So again, both hydrogen and oxygen become stable along the process, and the resulting Lewis structure, if you would represent the shared electrons in terms of a covalent bond or a bonding pair, it will look like this. Has 2 bonding pairs and 2 lone pairs. Okay, so hindi ko po alam kung napapansin nyo, pero may pagkakahalin tulad po ang structures nitong tatlong molecules ito: methane, ammonia, and water. So itatabulate natin lahat ng ating mga information na na-gather as we worked on the Lewis structures of these compounds. So sana po nare-recall nyo or nag-take down kayo ng notes. Ano po? Okay, narito na po ang Lewis structures ng tatlong compounds na ating ginawa kanina or inaral kanina. So methane has 4 carbon-hydrogen single bonds. So it is surrounded by 4 bonding pairs. It doesn't have a lone pair. Okay? Pagdating naman sa ammonia, how many bonding pairs does it have? Bibilangan nyo lang po yung covalent bonds. 1, 2, 3. So it has 3 bonding pairs and each bonding pair is composed of 2 electrons, right? And it has 1 lone pair. So yung pair ng electrons na kay ano lang siya, kay nitrogen lang siya. In the case of water, it has how many bonding pairs? So bibilangan lang natin ang oxygen-hydrogen covalent bonds. So 1, 2. So meron tayong dalawang bonding pairs. Meron din tayong dalawang lone pairs. So electrons that are not being shared by not being shared by oxygen. Ibang kahalagahan ng pagbibilang ng bonding pairs at saka ng lone pair. So tatandaan lang po natin, electrons, whether it be a bonding pair or a lone pair, they occupy space in around the central atom. So in this particular case, ang central atoms natin is yung carbon, yung nitrogen, and yung oxygen. So kung titingnan nyo sa flat surface, itong methane, ano ba yung separation, degree of separation between two hydrogen atoms? So baka tingnan mo sa on a flat surface, baka ano siya, 90 degrees. Hindi po yan. In reality po, this is a model of methane. So each of these white circles would represent a hydrogen atom, and this stick connecting a hydrogen atom with a carbon atom represents the bonding pair. So if you would notice po, this forms what we call a tetrahedral structure. Bakit siya tetrahedral structure? It is because in a tetrahedral structure, doon po na ma-maximize yung separation between two bonding pairs. Bakit kailangan i-maximize yung separation? Ano ba ang meron dito sa bonding pair? It is composed of electrons. And electrons are negatively charged particles. So negatively charged, ito negatively charged din. Ano ba nangyayari kapag if you have if you have particles of the same charges? So they repel. Ayaw nila sa isa't isa. So in order for methane to be stable, it needs to maximize the separation between these pairs or these hydrogen atoms. So and that particular maximum separation is achieved in a tetrahedral structure. Ano po? So methane has a tetrahedral structure. Now, pagdating naman sa ammonia, ang gusto ko po pala i-point out dito, pag i-combine ninyo yung number ng electron pairs around it, whether it be a bonding pair and a lone pair, this is equal to 4. This is also equal to 4. This is also equal to 4. So meron pong relationship ang structures nitong tatlong molecules na ito. Kasi yung total number ng pairs of electrons around them is the same for all. Nag-iiba-iba lang siya, bonding pair or lone pair. So in this particular case, yung ammonia has 3 hydrogen atoms around it, and then yung kumbaga itong nasa taas na yan, tanggalin natin yung isang hydrogen. So wala ka ng hydrogen atom dyan. Naging lone pair na lang siya. But as I said, a lone pair also occupies space because it is composed of electrons. So itong electron pair na to would still push the other electron pairs away. So technically, yung parent structure hindi nagbabago, na wala lang yung hydrogen dito. Pero as you look at the structure of it, ang structure po ng compound is only based on the shape of or the orientation of all the atoms surrounding a central atom. So since ito hindi muna siya nagka-count sa geometry, ang shape po ng ammonia is actually not a T-shaped structure, just like what you would see on a flat surface. It is a trigonal pyramid. Pagdating naman po sa water, so ano nangyari po sa water kasi, in comparison to the tetrahedral parent structure, yung dalawang bonding pair ay napalitan ng lone pair. So magtanggal tayo ng dalawa. Isa, dalawa. So ito, naging lone pair na siya. Ang natira na lang sa atin is dalawang oxygen-hydrogen bond. Oxygen-hydrogen bond. At ano yung shape na yan ng oxygen-hydrogen bond? It is a V shape, or we call this a bent structure. So water has a bent structure. So ito po yung medyo teaser natin sa VSEPR. Paano ang VSEPR is valential electron pair repulsion. So yun po ang teorya sa kung paano ba naka-orient lahat ng electron pairs around a central atom, and that determines the geometry around a central atom. So meron po tayong separate na session for that. Hindi po natin siya i-cover dito. Ginamit ko lang po siya para dito sa family of covalent compounds with 4 groups with 4 electron pairs around it.
Ngayong naaral na natin ang Lewis structures ng compounds na merong single bonding pairs or single covalent bonds at meron ding lone pairs. Ngayon, i-challenge naman natin ang mga sarili natin. Isulat natin or i-draw natin ang Lewis structures ng sumusunod na compounds kung saan kailangan nating mag-form ng multiple bonds.
So, una po nating example para naman po sa covalent compounds na merong multiple bond is the case of oxygen. So oxygen molecule is composed of 2 oxygen atoms, and each oxygen atom in its neutral state should have 8 electrons. So hindi ko na pinakita yung electronic configuration, but just pay close attention to this. So these are the Lewis symbols for each oxygen atom. This is a covalent compound kasi parehas non-metal yung nagko-combine, huwag niyong kakalimutan yan. Pag parehas non-metals ang nagpo-form ng bond, they usually form a covalent bond. So now, paano tayo magpo-form ng covalent bond? Kailangan muna nating pagsamahin ang dalawang unpaired electrons. So ito muna, pagsamahin natin yung dalawang nasa gitna. What structure do you get out of it? So the intermediate structure that you get out of this looks like this. So i-represent natin itong bonding pair na ito by a single covalent bond. And then, we always have to make sure yung electron accounting, ang total number ng electrons po for the entire system, hindi siya nagbabago. So itong electron pair na ito is represented by the oxygen-oxygen single bond. So isulat natin, meron siyang dalawang lone pairs, meron isang unpaired electron. Same here, dalawang lone pairs and isang unpaired electron. So now, what we have to do is kailangan natin bilangan ilan bang electrons ang nasa paligid ng oxygen dito. So oxygen has how many non-bonding electrons? So 1, 2, 3, 4, 5. And then, in addition to the 5 electrons, meron kang electron pair dito, which makes it a total of 7 electrons. 7 electrons. In the case naman of oxygen here, it has 1, 2, 3, 4, 5 plus 2 electrons from the covalent bond. It also has a total of 7 electrons. So is this already a stable configuration for oxygen? The answer is no, because kailangan makasunod to sa feng shui. 8 is a lucky number. So kailangan gusto namang elements na yan, meron silang 8 electrons na nakapaligid sa kanila. So another option that we can do is to combine these unpaired electrons to form another bond between the 2 oxygen centers. Ang magiging resulting structure mo will have a double bond between the 2 oxygen centers, and then again, don't forget to keep an accounting of the lone pair. So merong dalawang lone pairs per oxygen atom. Okay, now, so ano na yung structure natin? Ang structure natin may double bond between the 2 oxygen atoms, may dalawang lone pairs around each oxygen atom. So magbilang ulit tayo ng electron. Ilan yung electrons around the first oxygen atom? So you have 1, 2, 3, 4, and then you have 2 double bonds. So 2 times 2 electrons is equal to 4. So that makes the number of electrons around this oxygen center 8. So 8, octet, kompleto na, stable siya. How about this one? So since it's a symmetrical molecule, dapat parehas lang siya, no? So 1, 2, 3, 4 plus 4 electron pairs from the 2 covalent bonds. So that makes it 8 electrons. So this is a stable Lewis structure for an oxygen molecule. Okay, mapunta naman tayo sa case ng nitrogen molecule. So a nitrogen molecule is composed of 2 nitrogen atoms, and nitrogen in its neutral form has 7 electrons each. So again, hindi ko na ipapakita sa inyo yung Lewis structures bilang ang electronic configuration bilang kayo po yung mga expert na ano po. So pinakita ko na lang po ang Lewis symbol for nitrogen. So Lewis symbol, okay, medyo may mali dito, kulang ako dito ng isa. So kami man po ay nagkakamali din. Nakakaligtaan. Okay. So each nitrogen atom should have 5 valence electrons around it. In this particular case, nitrogen has 1 lone pair and 3 unpaired electrons. 1 lone pair and 3 unpaired electrons. Ano po? So, isa pang makakatulong sa inyo, dahil sa mga teachers sa pagtuturo at sa mga estudyante, para hindi kayo malito, is try to write your structures in as symmetrical as possible para mas madali sa inyong ma-imagine. So, in this particular case, pinaba ko silang mirror images. So, paano ba yan nakakatulong? So, whenever we are forming covalent compounds, kailangan, again, sharing of electrons. So, these unpaired electrons should be shared between the 2 nitrogen atoms. So ano bang intermediate structure na makukuha mo dyan? So once you follow that, you will have a single bond between the 2 nitrogen centers. And then again, wag kakalimutan, meron tayong accounting ng electrons. Dapat yung total number ng electrons around the system should be conserved. Walang nawawala. So isulat muna natin yung lone pair sa magkabilang dulo. And then, meron silang tig-dalawang unpaired electrons. So now, check natin. Ilan ang electrons around nitrogen? Is this already a stable structure? So 1, 2, 3, 4 for the non-bonding electrons plus 2 from the covalent bond. That makes it like 6 electrons. Hindi pa siya stable. Dito, ganun rin. 1, 2, 3, 4, 5, 6. So 6 electrons. So ibig sabihin, kailangan pa nilang mag-share ng mas maraming electrons. So ang gagawin naman natin, itong electron pair na ito, kukombine din natin. So therefore, magkakaroon tayo ng pangalawang covalent bond between the 2 nitrogen centers. So sulat muna natin yung base structure. Masabi natin, dalawang covalent bonds. And then, wag natin kakalimutan sa magkabilang dulo ng guhit na ito or ng symbol na ito ay may lone pair. At since pinag-combine na natin ito, tig-isa na lang sila ng unpaired electron. So, nasusundan niyo po ba? Okay, magbilang ulit tayo ng electrons. Ilan ang electrons around nitrogen here? 1, 2, 3. So, 3 non-bonding electrons plus 4 since may double bond kayo dito. So, that makes it 7 electrons. In this particular case, 1, 2, 3 plus 4, 7 electrons. So, stable na ba siya? No. Ano yung requirement natin? Again, sabi nga, dapat octet. Dapat wala yung electrons. So, ibig sabihin nun, kailangan pa nating ipag-share itong dalawang unpaired electrons na yan. So, that means na ang ating resulting structure will have a triple bond between the 2 nitrogen centers. And again, sabi ko, dapat hindi kakalimutan yung mga electrons na hindi pinag-combine. So in this, natitira lang ay yung tig-dalawang electron for each nitrogen or yung natitirang isang lone pair for each nitrogen center. So magbilang ulit tayo ng electrons. 1, 2, plus 6 since may triple bond kayo dito. So that means this has 8 electrons around it already. So stable na yung nitrogen dyan. In this case as well, 1, 2, plus 6 makes it 8 electrons. So therefore, ang stable or ang tamang Lewis structure for a nitrogen molecule should be this. So there's a triple bond between the 2 nitrogen centers, and then each nitrogen center should have a lone pair. Okay, so yun po, nakagawa na tayo ng example ng double bond, nakagawa na tayo ng example ng triple bond between a diatomic molecule. So this time naman gawin natin tatlong atoms ang bubuo dyan. Paano tayo mag-form ng multiple bonds? So gawin naman natin to sa case ng carbon dioxide. Okay, so gaya pa na nakasanayan natin sa ating mga web lectures at web tutorials, pagkatapos natin ng basics, papahirapan naman natin ang buhay nyo. Hindi pwedeng ako lang po yung napapagod dito. Ano po? Okay, so carbon dioxide, kailangan natin isulat ang kanyang or kailangan natin i-draw ang kanyang Lewis structure. Okay. So, nandito po tayo, sinulat ko na yung Lewis, so ina-assume ko na experts kayo sa electronic configuration at sa pagsulat ng Lewis symbols ng mga elements dito. So, nandito po ang Lewis symbol for carbon and for oxygen. So carbon has 1, 2, 3, 4 unpaired electrons around it. Oxygen has 2 electron pairs or 2 lone pairs and then 2 unpaired electrons. So paano ba natin ito gagawin? So again, covalent bonding, kailangan yung mga unpaired electrons ay magko-combine or para will be shared between 2 elements. So simulan natin yung bonding framework. Isa lang tip, whenever compounds form or whenever elements form a particular compound, nature likes symmetry. Gusto niya symmetric. So carbon po, I had put it in the middle. And then yung dalawang oxygen atoms nandun sa gilid. And one very important thing po, if you want to be very systematic about this, the central atom should always be the atom with the lower electronegativity. So electronegativity, I have mentioned that earlier when I discussed ionic bonding. So electronegativity is the ability of the element to draw electrons towards it or to attract electrons. So yun po yun when they form covalent bonds. Mas mataas po ang electronegativity ng oxygen kumpara sa carbon, so therefore it makes sense na ilagay ang carbon sa gitna. Okay, so combine natin to. Itong dalawang electrons sa to form a bond between carbon and oxygen, and also same for the other side kasi sabi nga po natin gusto ng nature ang symmetry. So what structure do you get out of this? So kung susundin po natin, i-represent na natin in terms of single bond yung electron pair na yan na na-share. And then may natirang dalawang unpaired electrons around carbon, and then isusulat ulit natin yung lone pairs around oxygen. There is one more unpaired electron around oxygen, one more here, and then the 2 lone pairs. Okay, so magbilang tayo. Ilan na bang electrons around each atom? So ilalagyan ko ito ng division kasi baka malito kayo. Okay, ilan ang carbons around oxygen? So 1, 2, 3, 4, 5, and then dalawang electrons. Oxygen has 7 electrons around it. So stable na ba yan? Hindi pa kasi kailangan 8. Demanding to mga elements na to eh. So carbon has 2 unpaired electrons and then 2 bonding pairs. So 2, 3, 4, 5, 6. So 6 electrons. On the other hand, yung oxygen dito is very similar to that one. It also has 7 electrons around it. 1, 2, 3, 4, 5, and then the 2 electrons shared between carbon and oxygen. So that makes it 7. Ang pwede pa natin gawin is itong dalawang unpaired electrons na yan ay pagko-combine to form a double bond. Okay, so paano ba yan? So isulat ulit natin yung structure. Carbon. So meron na ngayong double bond between carbon and oxygen. And then what happens is you should not forget that oxygen has 2 lone pairs. Okay, so in this process, magbilang po tayo ng electrons. Okay, so magbilang po tayo. Ilan ang electrons around carbon? So carbon has how many bonding pairs around it? It actually has 1, 2, 3, 4. 4 bonding pairs. Ilan electron per bonding pair? So that's 4 times 2 electrons equals 8. So therefore, it has a complete octet. So stable na siya. It's isoelectronic with neon. So when it comes to oxygen, it has 1, 2, 3, 4 electrons, and then the 2 bonding pairs here comprising another 4 electrons. Therefore, meron kang 8 electrons around oxygen. 8 electrons din dito. So ang Lewis structure po, it should look like this. So carbon has 2 carbon-oxygen double bonds to satisfy its requirement for an octet of electrons, and then oxygen is also doubly bonded to the carbon center, and each oxygen has 2 lone pairs. Okay, so ganoon lang po siya. So we can do it stepwise. Isa-isa puhin po natin pag-combine yung unpaired electrons, and then sa nakita po natin, it will reach a configuration na medyo kulang pa po sila lahat sa octet. So we have to keep combining the electron pairs in order for us to achieve a structure that satisfies the octet requirement for each element comprising the compound. So yun po. At isa pa pong tip na gusto ko lang sabihin sa inyo. So kung titingnan nyo po yung Lewis symbol for oxygen and carbon. So carbon has 4 unpaired electrons around it. And so what this means is that when carbon forms covalent compounds, it can only accommodate a total of 4 bonds around it kasi meron kang 4 unpaired electron. So 4 bonds, maximum 4 bonds for carbon. In the case of oxygen, meron siyang 2 unpaired electrons. So oxygen, when they form covalent compounds, they can only form 2 covalent bonds. Okay, 2 single bonds or 1 double bond. So nakita niyo po dito, meron siyang double bond. Consistent po ano po. So simple lang siya. So kapag expert na kayo sa pagsusulat ng Lewis symbols for each element, madali nyo nang ma-anticipate. Paano ba yung structure nito? You have to consider electronegativity. Again, dapat nasa gitna yung pinakamababa ang electronegativity na element. And then after that, nature loves symmetry. So kailangan i-arrange niyo yung mga atoms in such a way that you can come up with the most symmetric structure possible. In this case, nasa gitna ang carbon ng 2 oxygen. Alright, so on to the next example. We do have hydrocyanic acid, so HCN. So dito, binigay ko na yung atomic numbers nila. So hydrogen has 1, carbon 6, nitrogen has 7. So therefore, for all of their, in their neutral state, they have 1, 6, and 7 electrons respectively. So, hindi ko na din gagawin yung electronic configuration kasi baka magsawa na kayo. So, tumiretso na ako sa Lewis symbol. So, hydrogen has 1 unpaired electron around it. Carbon has 4 unpaired electrons. Nitrogen has 1 lone pair and 3 unpaired electrons. So, again, gaya na ginawa natin kanina, ano nga pong sinabi natin? If you have a polyatomic molecule that is medyo mahirap siyang gawing symmetrical, ang key decision na gagawin ninyo is that the central atom has to have the lowest electronegativity. And in this particular case, carbon is the central atom. And another very important thing whenever carbon is involved in, or whenever carbon forms covalent compounds, it should always be one of, if not the central atoms. Okay, so in this particular case, 3 lang po ang ating element, so therefore, nasa gitna ang carbon. Especially yan. Gusto niya nasa sentro siya. Alright. So we have to combine unpaired electrons to form covalent bonds. So simulan muna natin ito. Since nasa gitna yung carbon, syempre kailangan merong carbon-hydrogen bond. And you know, by doing this, it already satisfies the requirement for hydrogen to be stable. So it only needs a pair of electron around it. So therefore, merong carbon-hydrogen single bond. And then, simulan natin sa carbon-nitrogen single bond. So what structure do we get out of this combination? A single bond between carbon and nitrogen and a single bond between carbon and hydrogen. So kaya nang sinabi ko, whenever you are coming up with intermediate Lewis structures, you should not forget to account for the electrons. So originally, meron pang 2 unpaired electrons around carbon. Nitrogen has 2 unpaired electrons and 1 lone pair. So, pwede pa uli natin pag-combine ito, 2 unpaired electron na to. So, you will be getting this structure. And then, carbon has 1, 1, 1, 1. So bakit hindi ako tumigil dito? So kung magbibilang po tayo dito ng number ng electrons, dito ang masaya lang is hydrogen. So kasi meron na siyang 2 electrons around it. Carbon has how many? 2, 4, 5, 6. It has 6 electrons around it. And then nitrogen has 1, 2, 3, 4, 5, 6. So, nitrogen has 6 electrons around it. So, ang stable lang po dito is hydrogen. And when they form compounds, hindi pwedeng isa lang yung masaya. Dapat everybody happy. So, yun po yung tatandaan nyo. So, dapat yung carbon and nitrogen should have an octet of electrons. So, pagdating po dito sa structure na to, magbilang tayo. 2 electrons for hydrogen. Ilan na ang carbon? So, meron kang isang unpaired plus 3 bonds. So, 6 plus 1 makes this 7 electrons. This has 1, 2, 3. 3 non-bonding electrons plus 2 bonds here, so that makes it 4. So a total of 7 electrons. So therefore, kapos pa ng tig-isa. So in order to satisfy the requirement for an octet, kailangan itong unpaired electrons ay mag-combine pa rin. So, ang makukuha niyong structure upon doing this will look like this. So, there's a carbon-hydrogen single bond or single covalent bond, and then there's a triple bond between carbon and nitrogen nitrogen has one lone pair remaining. So ngayon, magbilang tayo. Ilan ang electrons around hydrogen? So dalawa. So happy ang hydrogen. Ilan around carbon? So carbon has how many bonds around it? 1, 2, 3, 4. 4 bonds. Each bond is equivalent to 2 electrons. So 4 times 2 is equal to 8 electrons. In the case of nitrogen, meron kang 3 bonds. So 6 electrons yan plus 2 electrons in your lone pair. That makes it 8 electrons. So again, like easy peasy, right? Carbon should always be a central atom. So ngayon naman, pupunta tayo sa polyatomic molecules where there is more than one central atom. So gagawin na natin itong mga challenge problems na ito.
Okay, so ipinakita ko na sa inyo isa sa mga pinakasimpleng pamamaraan sa kung paano natin i-draw ang Lewis structures gamit ang Lewis symbols. So ngayon naman, i-challenge natin ang ating abilidad na mag-draw ng Lewis structures sa pag-solve ng problems involving polyatomic covalent compounds na merong higit sa isang central atom. Pero bago tayo gumawa ng mga mas komplikadong structures, kailangan meron muna tayong strategy at ito po ang ibabahagi ko sa inyo. So unang-una, we have to determine the total number of valence electrons. And gaya na sinabi natin kanina, yung bilang ng valence electrons available that should be present in the Lewis structure. Pangalawa, we have to identify the central and the terminal atom. So binigyan ko kayo kanina ng guide. Ang carbon, palagi siyang central atom. Ang hydrogen, palagi siyang terminal atom. Ang atom na merong pinakamababang electronegativity, typically sila ang nagiging central atoms din. Pangalawa, kailangan marunong tayong mag-draw ng plausible skeletal structure or arrangement ng lahat ng atoms na bumubuo ng covalent compound. At ito ang basehan kung paano sila nagfo-form ng chemical bonds at ng structures. At pagkasulat naman po natin ng ating plausible skeletal structure, ang kailangan natin gawin ay pagdugtong-dugtongin natin ang mga atoms sa ating skeletal structure gamit ang single covalent bond. So pagkatapos natin silang i-connecta gamit ang single covalent bond, kailangan uli nating bilangan kung ilang electrons ang ating nagamit. At tatandaan, ang isang covalent bond ay equivalent sa 2 electrons. Ngayon, sa pagbuo natin ng skeletal structure, kapag merong sumobrang valence electrons na hindi nagamit sa pag-form ng covalent bond, pwede natin gamitin ang sobrang electrons para kumpletuhin ang octet requirement ng terminal atoms. Kapag ang resulting structure ay meron ng complete octet for all the atoms composing the molecule, ibig sabihin ito, posibleng tama na ang structure na inyong isinulat. May mga pagkakataon na pagkatapos natin kumpletuhin ng octet of electrons ng terminal atoms ay meron pa rin sobrang electrons. So, ang pwede natin itong gamitin para kumpletuhin naman ng octet ng central atoms. Ngunit, may mga pagkakataon din naman na hindi sapat ang lahat ng valence electrons para makumpleto ang octet requirement ng lahat ng central atoms. At kapag nangyaring nagkulang ito, dito na magsisimula tayong mag-form ng multiple covalent bonds. So muli, napakarami po nitong guidelines na ito. Medyo mahirap itong basta-basta na lang ipabasa sa mga estudyante. So mas madali po itong matututunan, mas tatatak po sa atin yung strategy na ito kung tayo ay magpa-practice, kung i-apply natin sila sa pag-draw ng Lewis structures ng more complex covalent molecular compounds.
Okay, so unang example po natin ng covalent compound na merong more than one central atoms is represented by this formula. So C2H6. So ito po ay tinatawag natin na ethane. So for ethane, ang challenge po sa atin is kailangan natin isulat or i-draw ang kanyang corresponding Lewis structure. So Pagdating po dito sa mga ganitong examples na more like na meron po tayong more than one central atom, medyo kailangan natin ibahin yung sistema at i-apply natin siguro yung mga ginawa natin kanina sa mga simpler examples where we only have one central atom. So in this particular example, mahalaga muna po na magbilang tayo ng total number ng valence electrons na meron ang lahat ng elements comprising this molecular formula. So C2H6. So we know from the electronic configuration of carbon that each carbon has 4 electrons, right? And since we have 2 carbons, we have to multiply this by 2. So therefore, ang total contribution ng ng carbon when it comes to valence electrons will be 8. In the case of hydrogen, we have 1 valence electron per hydrogen atom, but since we have 6 hydrogen atoms, so therefore, we have 6 electrons from hydrogen in total. So if we would combine these numbers, we have a total of 14 electrons. So tatandaan po natin yan. Itong number ng 14 valence electrons ang kailangan natin i-distribute to come up with the correct structure for ethane. So ang pangalawa po nating step is we have to come up with plausible skeletal structure for ethane. So when we say plausible skeletal structure, kailangan natin i-consider yung some of the rules that we mentioned earlier. So first and foremost, kailangan yung carbon typically is a central atom. So and then secondly, since it's a central atom, yung hydrogen is always a terminal atom. Pwede nating, there's a bunch of different ways by which we can arrange these elements as well. Ano pa yung dapat natin i-consider? So nature loves symmetry. So we have to arrange the carbon and the hydrogen atoms in the most symmetrical way possible. So una po, so carbon, we can put them side by side. And then, yung hydrogen atoms naman po, pwede nating ipaligid dyan. So hydrogen dito, hydrogen dyan. So since anim siya, paligiran natin ang kada carbon ng tatlong hydrogen. Okay. So ang bakit ba natin pinilang kanina yung number ng valence electrons? So binilang natin yung number ng valence electrons kanina in order for us to account for the bonds that are required to form a structure. So unang-una, ang gagawin po natin is when we say skeletal structure, we have to first connect all the atoms with one covalent bond for every pair of elements. So ang gagawin po natin is una, mag-form tayo ng carbon-carbon bond. So that's already one covalent bond. And then lahat ng carbon, ikabit natin dun sa nakapaligid na hydrogen. Ang gagawin naman natin is, magbibilang tayo. Ilan ba ang covalent bonds na na-form natin? So we had formed, ito mahalaga po na marunong tayo magbilang dito, ano? So 1, this is the first carbon, this is the carbon-carbon covalent bond, and then 2 carbon-hydrogen bond, 3, 4, 5, 6, 7. So we formed 7 bonding pairs or 7 covalent bonds. So 7 bonding pairs times 2 electrons per bonding pair would give you a total of 14 electrons. So ibig sabihin, in order for ethane to form this way, nakagamit siya ng 14 electrons, and that corresponds to the available number of valence electrons. So kapag dumating po kayo dun sa ganung point na nagamit nyo na lahat ng valence electrons available out of 2 carbons and 6 hydrogens, that could be an indication na baka nagawa nyo na yung Lewis structure ng maayos. So tatanggalin ko po itong mga labels na ito para mas makapagbilang tayo ng maayos ng electrons around each element. So tingnan muna natin yung in the case of hydrogens. So in the case of all the hydrogen atoms in this particular example, each of the hydrogen has 2 electrons. Is this a stable configuration for the hydrogen atoms like in this structure? The answer is yes. Right? Okay, now, magbilang tayo ng electrons around carbon. Ilang bonds meron sa carbon? 1, 2, 3, 4. So, 4 bonding pairs around carbon. Meron bang lone pair? Wala. So, 4 bonding pairs multiplied by 2, that means na kada carbon atom natin is merong 8 electrons each. So this is the Lewis structure for ethane. So you have 4 covalent bonds around carbon. And again, does this satisfy the requirement? So yung now electron counts, yes, octet for the carbon, doublet for the hydrogens, and then symmetric yung structure. All hydrogen atoms are terminal atoms. So tatandaan yun, ang hydrogen atom is always a terminal atom. And then carbon, whenever they form compounds, it is often a central atom. Okay, so next example naman po tayo. We call this ethylene. So C2H4. So same thing that we did earlier. Susundin lang natin yung mga steps na ginawa natin. So unang-una, kailangan natin bilangin yung total number of valence electrons. So
Again, carbon has 4 valence electrons around the second shell. So 4 electrons times 2 carbons would give you a total of 8 electrons, or 8 valence electrons contributed by carbon. In this particular case, meron tayong 4 hydrogen atoms. So each contributing 1 electron, so therefore meron tayo dito 4 electrons.
So yung total number of electrons that you have, or valence electrons that you have for the system, is 12 electrons. So again, ito yung ating gagamiting basis for coming up with the structure. So the next step is we have to come up with the skeletal structure. So probable skeletal structure. Ano ulit yung sinabi natin? Carbon should always be a central atom. Hydrogen should always be a terminal atom. So, and then nature loves symmetry. So kailangan symmetric yung distribution natin ng lahat ng atoms. So ito ba ay plausible skeletal structure? The answer is yes, because it satisfies some of our requirements. Dapat central atom, symmetrical, terminal atoms, dapat lagi ang hydrogen. Okay, so what we do is we try to connect the skeletal structure with single bonds. So this is how we're gonna do it. Connect the carbon-carbon bonds with a single bonding pair. The carbon-hydrogen bonds as well. So this is the structure that you're gonna get. And then what you're gonna have to do is that you have to count. You have to count the number of electrons required to form these bonding pairs. So you have 1, 2, 3, 4, 5 covalent bonds. So 5 bonds times 2 electrons each will give you 10 electrons. Okay? Meron ka 10 electrons na nagamit, but you have a total of 12 valence electrons available to form the structure. So you have a choice of either putting that pair of electron in the form of, say, unpaired electron for each carbon. And then what we have to do is we have to count. Okay, magbibilang po tayo. Ano po? Ilan ba ang number ng electrons for each carbon? So we have 1 unpaired electron plus 3 bonds, so 6 plus 1 is equal to 7 electrons. Same here. 6 electrons from the covalent bond plus 1 unpaired electron gives you 7 electrons. So what you can do, similar to what we did earlier po, is we can combine these to form another covalent bond. So that gives us a carbon-carbon double bond. And then same as earlier po, meron tayong dalawang carbon-hydrogen bond to each carbon center. So baka hindi nyo makita. Ayan po, ano po. Okay, so does this satisfy the requirement for a stable Lewis structure? Okay, magbilang po tayo. Ilan ang electrons around each hydrogen atom? So mayroon lang isang bond and each bond is corresponding to 2 electrons. So therefore, may 2 electrons ang hydrogen dyan, 2 electrons here, 2 electrons here, 2 electrons here. So are these hydrogen atoms happy? Yes, kasi completely filled yung kanilang orbitals. Now when it comes to carbon, how many bonds are there around carbon? So 1, 2, 3, 4. 4 bonds. Each bond contributes 2 electrons. So meron kang 8 electrons around carbon. In the case of this carbon, it's the same since symmetrical siya, so 8 electrons din. So therefore, this is a stable Lewis structure for ethylene. And just for your information, we call the first, yung una pong carbon-carbon single bond na ginawa natin, we call this the sigma bond. Sigma bond. Yung pangalawa po, o yung double bond, yung pangalawang bond, we call it the pi bond. So hindi mo natin siya i-discuss ngayon kung paano siya na-form because it requires an understanding of molecular orbitals and like orbital hybridization. So medyo next level po yan. Ano po? Okay, so this is the structure for ethylene. Okay, medyo mas pahirap po ito ng pahirap. Ano po? Our next compound is C2H2. So it's called acetylene. So meron kang dalawang carbons and dalawang hydrogens in this particular molecule. And as I have said earlier, how do we start or how do we approach the writing or the drawing of Lewis structures for these compounds? Kailangan muna po magbilang tayo ng number ng valence electrons. So
We have 2 carbons and 2 hydrogens each. So the electron configuration, valence shell for carbon has 4 electrons each. So 4 electrons times 2 carbons should give you 8 valence electrons from carbon. And then you have 2 carbons each, 2 hydrogens, each of which contributes to 1 electron. So therefore you have a contribution of 2 electrons from all of the hydrogens. And so if you would add this up, you would
get a total of 10 valence electrons. So ito ang ating the first step that we have to do is to draw a plausible skeletal structure. Yan. Carbon and carbon side by side, and then hydrogen is placed at the end of this lineup of carbons. So yan na yung possible arrangement yan in space. Kasi for example, kung gagawin nyo siya, no? Kung gagawin yung terminal atom of carbon at hydrogen, you cannot have 2 bonds between, hydrogen cannot have more than 1 bond. So this is already violating some of the rules that we made. So again, symmetry is key. Gusto ng nature ang symmetry. Gusto niya pantay-pantay lahat. Okay. So, what we do first is we connect the skeletal structures with a single covalent bond. So, carbon to carbon, carbon to hydrogen, carbon to hydrogen. And in doing so, ilang covalent bonds ang na-form natin? We formed 3 covalent bonds. So 3 covalent bonds would correspond to 6 electrons. So in this particular case, kung subtract natin 6 electrons, ano na lang yung natitira? We have 4 electrons left. So ang tanong ngayon, saan natin ilalagay? Saan natin ilalagay yung 4 electrons na yan? What we can actually do is pwede na natin gawin is we can distribute the 4 electrons in the form of unpaired electrons. Ilan ba ang electrons around carbon? So, dalawang bonds, so that accounts for, so the 2 bonds account for 4 electrons plus 1 and plus another 1. This will give you a total of 6 electrons for this carbon, and same here, 6 electrons rin. So what you can do, you can combine these electron pairs to come up with a triple bond. If you would rewrite that structure, what you're gonna get is something like this. So carbon triply bonded to another carbon, and then each carbon is capped with a hydrogen atom. And then now what we do is that again, we count the number of electrons around each atom. So again, for hydrogen, it has 2 electrons around it, 2 electrons around it. Okay, you're good. Now for carbon, we count. How many bonds are there around carbon? You have 1, 2, 3, 4. So therefore, you have 8 electrons. So this carbon is already happy. In the case of this carbon, it's the same. It's symmetrical. It should have 8 electrons as well. So therefore, for this particular system, you have a carbon-carbon triple bond. And as I have mentioned earlier, the first covalent bond that you form is called a sigma bond. The second and the third bond are considered pi bonds. Okay, so medyo straightforward na po siya. No? Nakikita niyo po ba yung progression? So, nag-start tayo from the most basic where all the atoms are connected with single bonds. But as we remove hydrogen atoms from this chemical formula, the carbon centers end up forming more than 1 bond in order to satisfy need to have an octet of electrons. So, requirement po talaga yan. Kailangan 8 ang electron sa paligid niya. Okay? Okay. So, more challenge problems. We are given a chemical formula of C2H6O. So, meron na tayong 3 elemento. Carbon, hydrogen, and oxygen. Okay. So, dito, again, magsisimula tayo sa pagbibilang ng valence electrons.
So, dito ang kasama dito sa electronic configuration. In the case of carbon, ang valence shell is nasa second quantum number. So, meron siyang 4 valence electrons per carbon, and then meron kang 2 carbon. So, therefore, you will get 8 electrons contributed by carbon in the structure. You have hydrogen. Meron kang isang electron, valence electron per hydrogen, but you have 6 hydrogen atoms. So, therefore, you are getting 6 valence electrons from hydrogen. In the case of oxygen, you have a total of 6 valence electrons, and then 2 plus 4 electrons in the s and the p orbitals. You have only 1 oxygen atom, so therefore, 1 oxygen atom, so therefore, you have 6 electrons. So,
then, let's add all of these up. 8 plus 6 plus 6 will give you 20 valence electrons. Okay? So 20 po. 20 ang gagamitin natin to form the Lewis structure. So again, ano ba yung mga sinabi natin kanina? So una, carbon should always be a central atom. Hydrogen should always be terminal atom, and then like oxygen could also be in certain cases could also be a central atom. So but one key thing that we have to consider here would be symmetry. Okay, so we have to come up with a plausible skeletal structure satisfying all those rules that I have mentioned. Ano po? So gawin muna natin symmetric. So, pwedeng central atom carbon, pwedeng central atom din ang oxygen. So, since kailangan natin siyang gawing symmetric, magsimula tayo dito sa ganitong plausible skeletal structure. Ilagay natin yung oxygen sa gitna, carbon, and then carbon. And then, ang gagawin natin, kailangan symmetric, meron tayong 6 na hydrogen. Ipaligid natin yung 6 na hydrogen around the carbons. So, this is as symmetrical as this structure could get. Ano po? Okay. Ang pangalan naman natin gagawin, gaya ng nakasanayan, is we are going to be connecting the skeletal structure with single covalent bonds. So 1, 2, 3, 4, 5, 6, 7, 8. So we formed 8 bonding pairs or covalent bonds, 2 electrons each. This will give you a total of 16 electrons, right? So 16 electrons na ang nagamit natin versus 20. So that means we have 4 electrons in excess. Saan natin pwedeng ilagay yung electrons na yan? So pwede natin ilagay yung electrons na yan around oxygen to complete its octet. So 4 electrons, you can give oxygen to lone pair. So now the question is, tama na ba ito? Is this a stable structure already? Magbilang tayo. Ilan ang electrons around each hydrogen atom? So, dalawa. So, therefore, hydrogens are placed properly. Now, each carbon, bilangin natin, ilan ang bonds around carbon? 1, 2, 3, 4. Are there lone pairs? There are no lone pairs. So, 4 covalent bonds times 2 electrons each would give each carbon atom 8 electrons. So, again, consistent with the octet rule. So, this is a good placement for the carbons. Now, oxygen, let's count. How many non-bonding electrons are there? So 2, 4, added to 2 covalent bonds. So that gives this oxygen 8 electrons as well. So therefore, this is what we consider a plausible Lewis structure. Okay, so ito po ay tama. And this molecule is what we call dimethyl ether. Dimethyl ether. But now the question is, are there other plausible structures for this chemical formula? Okay, the answer is, hindi ko muna answer yun pala. Alamin natin. Okay, so bubuk tayo ng ibang arrangement. So ito, ginawa natin to kasi we are trying to come up with the most symmetrical arrangement of all your atoms. But, gawin naman natin to. So, tanggalin muna natin yung structure ng dimethyl ether. So, hindi nagbabago yung bilang ng valence electrons. Ano po? So, we have 20 in total. What we can also do is, so this is a potential arrangement of the central atom. So, carbon followed by oxygen. And then now, what we will do is that we need to distribute the hydrogens. And whenever we are distributing hydrogens po, what we have to keep in mind is that alam natin yung Lewis symbol for carbon. So carbon should have 4 unpaired electrons around it. Oxygen should have 2 lone pairs and 2 unpaired electrons around it. So therefore, alam na natin na yung bonding requirement ng oxygen, it can only form maximum of 2 covalent bonds. Carbon can form 4 covalent bonds like an maximum. So when we distribute the hydrogen, kailangan natin siyang i-consider. Kailangan meron tayong 4 na groups around carbon and then 2 groups around oxygen. So 6 yung hydrogens na i-distribute natin. So ang pwede natin gawin is itong carbon na to will be bonded to this carbon obviously, so that is already 1 group. So since kailangan nito ng 4 na groups around it, so kailangan niya ng 3 hydrogen atoms. Okay. Ito naman carbon na to, it will be bonded to oxygen and carbon, so it already has 2 groups. So in order for it to satisfy the 4 group requirement, kailangan niya ng 2 hydrogen atoms. And then now, oxygen can form a maximum of 2 covalent bonds. So that means that this is already going to be connected to this carbon. So there is still an opportunity for you to attach another group at the very end, right? Kasi meron ka pang-anim na hydrogen. So you can attach, or you can connect this, or you can bond this hydrogen to this oxygen atom. And then what we have to do again is we have to connect the skeletal structure with single covalent bonds. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you have like 8 covalent bonds, 2 electrons each. So that means you have already used up 16 electrons. And so what that means is that you have 4 electrons in excess. So saan natin ilalagay yung electrons? Same thing. Ilagay natin sa oxygen. So we're giving oxygen 2 lone pairs. And then again, we'll do the same inspection. How many electrons are there for each hydrogen atom? So you have 2 because of the single bond, 2, 2, 2, 2, and 2. So all of the hydrogens are happy in this structure. Now you count the number of electrons around oxygen. So you have 2 covalent bonds, so that accounts for 4 electrons, and then 2 lone pairs, so you have a total of 8 electrons. So therefore, in this structure, oxygen is also happy, right? How about carbon? Carbon has 1, 2, 3, 4 covalent bonds around it. So therefore, it also has 8 electrons around it. It has an octet of electron, same as with this carbon. So 1, 2, 3, 4. So 8 electrons. Okay, so now, so this is also satisfying all the requirements of the Lewis structure. So, ang tanong, alin ba ang tama? So, ang sagot po is parehas po silang tama. So, ito po, this is a molecule which we call ethanol. So, ito ang active ingredient sa disinfectants natin. So, this is an alcohol that can kill viruses and bacteria. So, the relationship between ethanol and dimethyl ether, which I have shown you earlier, is what we call structural isomerism. So ethanol and dimethyl ether, they both have the same chemical formula, but they do have different arrangements of atoms in the structure. Okay? So again, parehas pong tama ang sagot na yan. So be careful po. At the moment you have more than one central atom in your covalent compound, there is a possibility for structural isomerism. So, huwag po natin kalilimutan yan. So, madali lang ano po. Okay, moving on. So, since medyo boring na yung lagi may hydrogen yung ating compound, so palitan natin yung hydrogen ng nitrogen. Is we have C2N2 as your chemical formula. So, again, similar to what I did earlier, we have to start with the counting of valence electrons. Both carbon and nitrogen have valence orbitals in the second shell. So, yung 2s at 2p orbitals.
So carbon has 4 valence orbitals each. Nitrogen has 5 valence orbitals each. And then we do have 2 carbons and 2 nitrogens in this structure. So
therefore, we have a total of 18 valence electrons. So itong 18 valence electrons na to ang kailangan natin gamitin sa pagbuo ng Lewis structures. Ano nga ba yung mga sinabi natin kanina? First, carbon is always a central atom. So it's always a given whenever it forms covalent compounds. And then secondly, elements with the lower electronegativity should be the central atom. Nitrogen is more electronegative than carbon. So therefore, whenever we are building or constructing a plausible skeletal structure, carbon should always be in the middle. And so what we have to do here is that we have to distribute the nitrogen symmetrically. So again, lagyan natin siya sa end ng dalawang carbon centers. And then what we do is, since, okay, may symmetry na satisfy your requirement for carbon to be a central atom, what we do is we connect the skeletal structure with single covalent bonds. We have formed 3 covalent bonds, and that accounts for 6 electrons already, right? So 6 electrons. Kailangan muna nating i-subtract yan dito. So 6 electrons. So therefore, we're left with 12 electrons. So ang una muna po natin gagawin, if you have that many excess numbers of valence electrons, is you use them up to satisfy the octet for the terminal atoms. So terminal atoms here would be nitrogen. So we have a total of 12 electrons. So satisfy muna natin yung octet. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So therefore, we have 6 lone pairs. So that means we have already used up the 12 electrons. So this becomes 0. Okay? So 0 na po. Wala na pong natitirang valence electrons. So now, let's count. Ilan na ba ang electrons around each element? So in the case of nitrogen, we have 2, 4, 6 non-bonding electrons plus 2 electrons from the covalent bond. Then you have 8 electrons here. 8 electrons here. So technically, oh, this is already good. This looks promising for nitrogen. But then the issue is that the carbon, how many electrons are there around carbon in the structure? So you have only 2 covalent bonds, so that accounts for 4 electrons. Do you have unpaired electrons or non-bonding electrons? No, you don't. So in this particular case, you only have 4 electrons per carbon. So again, ang konsepto po, ang requirement po ng Lewis structure, dapat everybody happy. Each atom should have an octet of electrons. So what we do is we can actually use some of the lone pairs here to form bonds with the central atom. Okay, so what we do is that this electron pair will be shared with that carbon. This electron pair will also be shared with that carbon. So forming carbon-nitrogen double bond. So ang makukuha po nating structure from this step would be, okay, carbon-carbon single bond and then carbon-nitrogen double bond. Right? And as I have shown you earlier, kailangan po lagi natin binibilang yung number ng lone pairs. So since itong dalawang lone pairs na yan is ginamit na natin to form a double bond with carbon, we only have 2 lone pairs for each nitrogen. Okay, so at this point, is this already a good structure? Let's count. How many electrons are there around nitrogen? So we have 2, 4 plus 4 from the double bond, and that gives this nitrogen center 8 electrons, so wala naman nagbago. So it's still good, right? In this case, 2, 4 plus 2 from the double bond, so that is also 8 electrons. Now for the carbon, how many electrons are there? So 3 bonds around it, so 6 electrons. 6 electrons here as well. So kulang pa siya, hindi pa rin siya masaya. Medyo makikihati pa rin itong carbons na ito from nitrogen. But what you also have to keep in mind is that you have more lone pairs here. So yung lone pair dito sa nitrogen, this can also be used to form another pi bond. So therefore, let's look at the structure. So single bond between 2 carbons and then 2 carbon-nitrogen triple bonds. And in this process, since ginamit na natin yung pangalawang lone pair, isang lone pair na lang ang natitira sa nitrogen. Now magbilang tayo. Ilan ang electrons around nitrogen? So you have 2 from the lone pair and then 6 from the triple bond, so that gives you 8 electrons. Same here, since it's a symmetrical structure, so 8 electrons. Now how about carbon? How many bonds are there around carbon? So 4 bonds around carbon, so that translates to 8 electrons. Same here. So is this a plausible Lewis structure for this compound? The answer is yes. So again, so galing po dun sa mga steps na ginawa natin kanina, using like simpler molecules, using dinitrogen, we're just combining some of those steps. So dapat po hindi natin nawawala yung grasp natin ng mga basic requirements for based on the Lewis theory for us to be able to come up with the most plausible Lewis structures. Okay? So, pero ang key po talaga dito is we just have to keep practicing. Practice lang po ng practice. Okay? Okay, so this is another challenge problem. So in this particular case, we will be working on the Lewis structure of phosphoric acid. So naku, wala ng carbon, no? Sanay kayo sa may carbon. So ito, the same thing that we're gonna have to do is we have to count the number of valence electrons.
Hydrogen again, as usual, it only has one valence electron. Phosphorus has its valence orbitals on the third shell, so 3s2 and 3p3. So therefore, for each phosphorus atom, we have 5 valence electrons. In the case of oxygen, kailangan ko ba i-memorize yan? 6 valence electrons. So we have to count the total number of valence electrons based on the chemical formula. So you have
3 hydrogens times 1 electron each plus 1 phosphorus contributing 5 electrons each, plus we have 4 oxygen atoms contributing 6 electrons each. So this will give you a total of 3 plus 5 plus 24, giving you a total number of valence electrons of 32. Okay, so gaya ng sinabi natin kanina, after we count the number of electrons, we have to propose or we have to draw a probable skeletal structure. So again, ano yung guiding principles natin? So unang-una, hydrogen is always a terminal atom. So lagi siyang nasa gilid-gilid. Hindi siya special. Pangalawa, oxygen can also be essential atom, so that's already given. But then the most important thing is that the element that has the lowest electronegativity should be the central atom. And in this particular case, the least electronegative element is phosphorus. So siya yung ilalagay natin sa gitna. So showing a probable Lewis structure. So phosphorus yan, no? Phosphorus. Symmetrical. How do we arrange the oxygen atom? So pwedeng ganyan. Huwag muna natin ilagay yung bonds kasi baka malito kayo. Gawin natin siyang stepwise. Right? And then pwede natin i-connect pa rin yan sa isang oxygen. And then now what we have to do is we have to distribute the number of the 3 hydrogens. So pwede siguro natin ilagay siya dito. Pwede natin siyang ilagay dito. Okay. Now, this is one skeletal structure that we can also that we can perhaps propose like in the beginning, right? But one very important rule na nabanggit natin kanina is that first, nature likes symmetry. So ito symmetric naman siya, no? Kasi pag hinati nyo siya dito, yung left side is mirror image no right side. However, in this particular case, meron din isang requirement na kapag mas compact yung structure, kapag hindi siya masyadong pahaba, hindi siya masyadong kalat, mas preferred yun ng nature. So, is medyo mahaba yung arm niya. So, more likely, hindi siya maganda. At saka, bonds between 2 oxygen atoms, ito po tatandaan nyo, bonds between 2 oxygen atoms that are usually unstable. Not unless you're just dealing with an oxygen molecule, O2. Doon stable siya. Pero if you have like a polyatomic covalent compound, covalent bonds between 2 oxygen atoms are typically unstable. So hindi siya preferred. So pangit to kasi masyado siyang mahaba. Kailangan daw compact. So compact. Paano ba natin gagawin yan? Ito medyo mahirap-hirap po kasi talaga ito example na to. So we have phosphorus. 4 yung ating oxygen. So ipaligid natin yung oxygen sa lahat ng ipaligid natin yung oxygen sa phosphorus. And then we do have 3 hydrogens to distribute, right? So kailangan din natin symmetric. So perhaps dito sa dalawang gilid. And then isa na lang yung natitira, ilagay natin sa baba. Okay, so would this be a plausible Lewis structure? We can give it a try. Okay, so ang sabi, we have to connect the skeletal structure with single covalent bond. So 1, 2, 3, 4, 5, 6, 7. So we have used up 14 electrons already, right? So 14 electrons, so ano na lang yung natitira? We are left with 18 valence electrons. At anong sabi? Kapag may sobrang electrons, we have to use it to satisfy the octet requirement of the terminal atoms, right? So terminal atoms, 18. So kumpletin muna natin yung octet na lahat ng oxygen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so 18 siya. Nagamit na natin yung natitirang 18 electrons. So now, we will need to count. How many electrons are there around each hydrogen atom? So we have 2 electrons here, 2 electrons here, 2 electrons here. Okay, so that's actually good. So, masaya na yung hydrogen. In terms of oxygen, let's count. We have 2 lone pairs accounting for 4 electrons and 2 bonding pairs, additional 4 electrons. So you have 8 electrons here. That's the same thing here. 8 electrons. 8 electrons. 6 non-bonding electrons and 2 from the covalent bond. So you also have like 8 electrons here. You have what? 8 electrons around phosphorus. Okay, so, but is this the real structure? Kailangan po natin tingnan Oxygen typically prefers to have two bonds, right? So, kailangan meron siyang two bonds unless magkakaroon kayo ng imbalance ng charge dyan. So, in reality po, when it comes to phosphoric acid, so one of these lone pairs gets used to form a pi bond with phosphorus. So, this is an example of a system where, okay, so babaguhin ko yung structure. You have a phosphorus-oxygen double bond. So, hindi po nagbabago yung bilang ng electrons around oxygen, right? So, 8 pa rin siya. But the number of electrons around phosphorus, nagbago siya, naging 10 siya. So, the question is like, then hindi na siya octet rule. Bakit 10? So, 10 electrons around phosphorus. So, the reason why phosphorus can do this is because it is a bigger element, nasa period siya lower than the period where oxygen belongs. And in the case of phosphorus, is big enough, it has low-lying orbitals that can accommodate that extra electron. So, hindi natin siya i-cover ngayon. Pero, ito po yung example ng systems that can deviate from the octet rule. So, phosphorus can do this, sulfur can do this. But when it comes to our period 2, so yung hilera po ng boron, carbon, nitrogen, oxygen, fluorine atoms, whenever those elements form covalent compounds, they always strictly follow the octet rule. Just watch out for that. When you have phosphorus and sulfur, sometimes they deviate from the octet rule. Okay. So at this point po, ito na yung last example natin ng pagsulat ng or pag-draw ng Lewis structures of covalent compounds.
Okay, in summary po, medyo madami-dami po tayong natakal ngayong araw na to. So, inaral natin yung history ng Lewis theory. Pangalawa, natutunan natin ano ba ang pinagkaiba ng Lewis symbols sa Lewis structures at ano ba yung iba't ibang klase ng chemical bonding. So, inaral natin ang ionic bonding at ang covalent bonding. And most importantly, nakapag-practice po tayo sa kung paano ba mag-draw ng Lewis structures ng ionic compounds at ng covalent compounds. And specifically in the area of covalent bonding, inaral po natin ang konsepto ng bonding and lone pairs. Nagkaroon po tayo ng introduction sa VESPR or valential electron pair repulsion na atin pong aaralin sa ilan sa ating mga susunod na web lectures. Inaral din po natin ang multiple covalent bonds at higit sa lahat, nagkaroon po tayo ng introduction to atoms that can defy the octet rule. So gaya po na sinabi ko kanina, mas tatatak po ito, mas matututunan natin ang pag-draw ng Lewis structures by heart kung tayo po ay magpa-practice ng magpa-practice. So practice makes perfect. Ika nga. Marami pa po kaming kaalamang gustong ibahagi sa inyo na maaari po makatulong sa pagtuturo ninyo ng konsepto ng chemical bonding at molecular structure sa ating mga mag-aaral sa loob o labas man ng silid-aralan. Particular po, paano nakaka-impluwensya ang structures ng molecule sa kanilang properties? So gaya na nabanggit ko po kanina sa ating introduction, bakit polar ang water? Ano ang kinalaman ng structure sa polarity? Kanina ipinakita namin sa inyo ang geometry around central atoms, merong 4 na groups around them, yung introduction sa VESPR. Ano pa ba ang ilan sa mga molecules na mas komplikado ang structure at may iba-ibang hugis? So yun po, ito po ang ilan sa mga tanong na sasagutin po namin sa mga susunod po naming web lecture. So in particular, ang kasunod po nitong web lecture na ito will be a session on the valential electron pair repulsion theory. We will be discussing bond polarities. So yung konsepto ng electronegativity and electron affinity, atin pong papasadahan yan. Yung konsepto po ng bond orders, konsepto ng formal charges, atin pong itang isasama at higit sa lahat, ang pinaka-importante po will be the intermolecular forces of attraction and how they relate to bond polarities and structures. So yun po. So muli po, maraming salamat po sa inyong pag-uukol ng mahigit sa 2 oras dito sa ating web lecture. Nawa po ay meron po kayong nabaong kaalaman. Sana po yung mga teachers natin na binabalikan po itong konseptong ito. Nawa po ay na-refresh po ang ating pong pagkakaintindi sa chemical bonding at sa Lewis structures sa ating namang mga estudyante. Naway nakatulong ito para mas madali ninyong maintindihan ang konsepto ng Lewis theory and chemical bonding. So muli po, maraming salamat po sa inyong pagsuporta sa aming mga advokasya dito sa Filipino Science Hub. Patuloy po kayong mag-ingat at kita-kita po ulit tayo sa susunod po nating web lectures. Maraming salamat po at i-enjoy po ninyo ang natitirang oras ng inyong weekend.
Ayan. Thank you, Kuya Jeff, for that long and comprehensive discussion about Lewis structure. We're entertaining questions po. Actually, medyo wala namang masyadong questions eh. Ang mga questions lang medyo yung in general, parang ano daw yung core electrons and anong pinagkaiba niya sa ground state configuration. Yun yung nakita ko. Tapos, paano malalaman yung valence electrons? Kasi ang ginawa ni Kuya Jeff is based on sa electron configuration. Baka daw merong ibang technique to identify kung paano yung valence electrons.
Opo. So bali itong approach po na ginawa ko, ito po yung pinaka-basic na paraan at kumbaga yung pinaka-simpleng paraan para po matutunan niyo yung konsepto ng Lewis theory, yung pagsula or pag-draw ng Lewis structures in such a way na masasatisfy niyo lahat ng requirements. But definitely, kung napansin niyo po, may mga comments po ako about the formation of multiple bonds, yung lone pairs, kung paano ba sila na-form. Kailangan ko pong i-restrain yung sarili ko rin kasi those are touching on fairly more advanced concepts po ba sa chemistry at kailangan po meron po muna tayong prerequisite session po para po maipaliwanag sa inyo bakit ba halimbawa ba't nagpo-form ng pi bond. That is because of orbital hybridization. So as they form bonds in space, minsan naghahalo-halo po or nag-overlap yung mga orbitals, may bagong orbital na nabubuo. So medyo hindi po siguro appropriate na isabay ko po iyon dito. Pero I assure you po, itong paraan po ng pagkakaturo ko ng pagsulat ng Lewis structure in this particular lecture, kahit ipapanood nyo po ito sa mga estudyante, masusundan po nila ito. Now, the more advanced chemistry concepts po, kailangan po natin ng dagdag na lectures dyan. So, electronic structure, yung properties ng electrons, kailangan maipaliwanag po natin yan. Ano ba yung behavior nila as atoms form compounds. So, hintayin muna po ninyo na magbigay po kami ng prerequisite lectures doon, and then after that, titirahin po natin yung mga mas advanced po na topics or aspects of chemical bonding and structures. Meron po ako mga nakitang questions about nagpapasolve ng sulfur dioxide. So ang gagawin ko na lang po, wala po kasi akong whiteboard dito, nandun po sa taas. Yung pong mga specific questions na yun, we're taking note of them. Gagawin na lang namin, baka mag-shoot ako ng maiksing video para ipakita sa inyo paano ba sinusolve yun. Meron din pong para mga nalito about yung nitrogen daw having 5 valence electrons, and then after that, after mag-form siya ng covalent compound, bakit meron na siya mga lone pairs? I would like to apologize kasi hindi ko po alam kung anong slide yung kayo nagre-refer to. If it's an error on my notes, yung sa pagkakasulat ko sa board, or medyo hindi lang klaro yung pagkaka-explain ko, pero pakisend po sa amin ng message sa Filipino Science Hub kasi kung alam ko po yung question, we'll surely clarify that para po mas maintindihan po ninyo. Ayun po. Ito po ay simula pa lang. Ito po yung pinaka-basic na offering namin when it comes to molecular structures and chemical bonding. So, ang kasunod po namin dito dun sa follow-up lecture, yung po mga nagde-deviate, yung mga hindi sumusunod sa octet rule. So, hindi muna po namin sana mga yun kasi baka tumambling po tayong lahat. Wag po nating baka pumasyak ang ating pong karamihan ng mga nagpa-participate. Pero I appreciate po you sticking around kasi ang dami po ninyong nanood for 2.5 hours. So hopefully po meron kayong mga napulot. Sana po na-refresh yung mga medyo matagal nang hindi nakabalik dito sa konsepto ng Lewis theory, Lewis structures at pag-draw ng chemical structures. Pangalawa po, Bali ito po pangatlong web lecture na namin. Yung una po namin is atomic theory, and we touch on laws of conservation of mass, definite and multiple proportions. We also had a tutorial or a web lecture on oxidation states and balancing redox reactions. And then ito po yung pangatlo, Bali, what we do po is we upload all of them on our YouTube channel. So kung gusto nyo po ipa-review sa mga estudyante nyo, feel free to forward the link po to them. Kasi yun po talagang intention namin. Kaya po napansin nyo, sobrang stripped down po na pagkakaturo namin. Hindi po hanggat maaari kung pwedeng mas as simple as possible yung pagkakapaliwanag. Yung lengguwahe po is Tagalog-English para po yung mga batang medyo hirap din po makasumabay sa pagtuturo in English as a teaching medium. Para mas makarelate po sila. So para po sa mas nakararami po ang pagkakadesign po namin ng mga lecture materials na ito. Para wala naman atang ibang mga questions. And then, so please watch out po. Meron pa po kami mga masyadong offerings. Meron pa po kami ibang mga planong offerings over the next few months. Tutok lang po kayo. Alam po namin naging busy na rin kayo. And then, every once in a while po nga pala, we post polls, nagsusurvey po kami kung ano po yung mga topics na gusto po ninyong ma-refresh kayo. So we are paying close attention to that. And yung sunod nga po naming offering dito is yung online forum on science investigatory project. So mag-share po yung mga taga San Pablo High School na kanilang best practices, so kung paano po ba sila nakaka-come up ng very great bodies of research at the high school level. So sila po yung mga nananalo. So nagpa-unlock naman po sila, isa-share po nila sa inyo yung kanilang mga techniques, yung mga strategies po nila. So that will happen next week, Saturday next week. So I highly encourage all of you po to participate in that online forum. That will be a sharing. So they will be sharing a few things, and then we will open the floor to questions. And if you have been mentoring your students po to participate in science investigatory projects, we also highly encourage your students to dial in. Kasi para po ito sa, not only for teachers, this is also for our students. Ayun po. Parang wala naman na yatang ano pa ba? Molarity. Marami po. Yung kasunod pong target din namin is on the mole concept. So para mapaliwanag po namin yan sa inyo, yung mole concept, we're listening to your request, pero as we have mentioned po, we're all volunteers, so medyo pa isa-isa po yan, hindi po talaga namin siya one time big time ilalatag sa inyo lahat. So inuunti-unti po namin. So in the long run, over the next few years, ako po, ang personal goal ko po is to be able to come up with online contents po na friendly sa mga Pilipino, para yung mga nasa libro na advanced chemistry ay maging accessible po sa inyong lahat sa pamamaraan at sa lengguwaheng mas naiintindihan po na nakararami. Ayun po. Muli po, maraming salamat po sa inyo. May nakalimutan ba ako, Marty?
Yung announcement sa poster, kung kailan.
Ay, opo. Yung sa poster nga pala po, so we had the deadline for the poster slogan competition. So thank you so much po sa mga teachers na mga students na nag-participate. So we are in the process of judging or screening the entry. So bale, ang gagawin po namin dun is by the end of the month, i-announce namin yung top 12 na finalists. And then what will happen is that we will ask the top 12 finalists to upload 3-minute video vlogs explaining their work, featuring their work. And then 50% po ng final scores will will be based on the online votes. So magpapa-online voting po kami dun sa page. Para po ma-pick natin yung winner. So 50% from online votes and 50% from the judges' scores. So yun po. And then we also have an ongoing TikTok participation po. So by the way, kung gusto niyo po ng 1-minute videos to feature home-based experiments or 1-minute science trivias na pwede niyo po magamit sa pagtuturo sa klase, we are on TikTok po. You can follow PhilSci-Hub on TikTok. Meron po kami doon so far, 60 videos na uploaded na. Pwede niyo po yung i-share sa mga students niyo. And we highly encourage you all po to use the platform to also share science concepts. Kasi yun nga lang, medyo compact siya, pero it's fun kasi in yung TikTok sa mga kabataan ngayon. Ayun, meron pa ba? Yun, so may online forum po next week. Kung kaya niyo po, next week po, medyo mas maiksi na po siya. I promise you po, hindi siya 3 oras. Mas mabilis po siya.
Ayan. So, thank you, Kuya Jeff. Para po dun sa mga may gusto, kailangan ng certificate, na-post na po namin sa comment box ng Zoom and YouTube yung mga forms. So kailangan nyo lang po siyang i-accomplish. Tapos isesend na lang po namin sa inyo sa email within 2 weeks. Kasi po medyo marami po ang attendees ngayon. So please accomplish the form po kasi no form accomplished, no certificate po. Also, para po kayo ay makakuha ng certificate, dapat po kayo po ay follower ng aming Facebook page and subscriber ng YouTube channel para po dun sa mga nanonood sa YouTube. Yun lamang po for today and maraming salamat po for sticking with us. Alam ko po it's past lunch time na and sana po nakakuha na kayo ng lunch ninyo. Again, for next week, we will have the Science Investigatory Project, Best Practices from San Pablo Science High School to be delivered by Professor Ralph Alomia. Ayun lamang po, sana po ay magkita-kita pa rin po tayo next week for this event. And in behalf of the Filipino Science Hub members, maraming salamat po sa inyo. And again, this is Marty and we're signing out. Yung pong sa mga certificates, na-post na po namin sa comment box ng Zoom and YouTube. So hindi po muna namin i-end yung session para po makakuha kayo ng link. Yun lamang po. Thank you po.